2 working for? Test 1, 1, 1, 1, 1. Yeah. There you go. How about that right there? Yeah. Okay.
So we have one recording, it'll be the last presentation. And so the audio might be a bit loud on the PC. So
Okay.
is that something you can adjust?
Yeah. Do you wanna do a test run of it briefly?
I can't really set the audio without a lot of play and stuff.
Okay.
So we just heard it with you. Probably needs to be calm.
Yeah. Yeah, we can do that. Okay. And then, in general, if you want to roam around and stuff, use this one. We kind of purposely have the Vivian like here so it doesn't roam around. And then we have a wireless one for questions. Test 1, 2.
We'll get started in a couple minutes. Let's give a little time for rain appreciation.
Good morning, everyone. It's a lovely Dayton day outside, which we like to have whenever we have visitors in town. We have a few things to update about our various time frequency, software-defined radio, GPS, and all sorts of merges together projects this morning. And first, I'm going to start with the one that's not really great news. Last year, we introduced a 4-port GPS GNSS antenna splitter called the GUS, and it was designed to be a very inexpensive way to have multiple receivers off of one antenna that does not have the filtering that most splitters have that limits it to only using the L1 band. This is broadband, and we'll do L1, L2, L5. It's been very popular. It works well. A lot of people like it, but I chose an extremely tiny low noise amplifier chip, barely visible under the microscope size, but it was specifically designed for GPS applications and seemed like just the thing. It turns out that the company that we have manufactured the boards, JLC PCB in China, has had a lot of difficulty soldering those parts down and getting them to work. And we've had a chance to have some of the boards X-ray inspected, and there's kind of all sorts of different failures. It's just the pads are too small, they can't position and get the solder paste down properly. So we've had a failure rate of about 1/3 of the boards, which we've been pre-testing now. So everything that we send out to a customer works, and this doesn't seem to be a problem with intermittence. It's either going to work or it's not going to work. So we have products for sale. They will be fine, but my project right now is to redesign. There are lots of other low noise amplifiers available, and they may not be quite as optimized for this application, but they can do the job. So we'll be doing a new circuit board that uses a chip that will be more reliable to solder down, and hopefully it won't impact the availability at all. Hopefully it won't impact the price. It's just a design change that we'll have to make. New project that we've been working on is the GERT, which is a GPS DO, except I tend not to use those words in describing it because it's a little bit different than the traditional one. Interestingly, it came from a designer whose focus has been RF rather than timing. So he wasn't thinking about how you divide the pulse per second and do long phase loops. He just wanted something that would drive a software-defined radio. So Glenn Elmore, N6GN, came up with this board that is designed to be good enough to be the reference source for an HF SDR, like a Kiwi SDR or the RX888 receiver that you may be able to see at our booth and it's become very, very popular, that need 27 megahertz or 66 megahertz clock frequencies. So Glenn's board was designed to meet that need. It has 2 outputs that can be independently set for the frequency, very low cost, and it's just a way to get the frequency reference that'll work through HF. And actually, he's been using it for Whisper at 1296. So it's actually usable up into VHF as well. We're redesigning the board to make it a little bit more modular and to do what we called when I was working cost-reduced value engineering, which is that Glenn used one component that's very expensive, and we're trying to replace that with a much less expensive one to lower the cost. And if that works, we're hoping that we'll be able to sell this for less than $100. That's compared to about $170 for the Bodner Mini GPS DO. And I'll tell you up front, this is not as good as the Bodner, but it's good enough, and if we can make it down near half the price, we think it's something that people will be interested in. We have hardware that works, although we're still tweaking it, but the big problem is that Glenn used an Arduino IoT33 Arduino board that has a built-in Wi-Fi chip, and He did that because this was originally part of a much more complex a multi-band transceiver project that he's worked on, and the other pieces also used a web interface. You don't really need that to set up a GPS DO. You're just setting the frequency and a couple of other things. And that Arduino board costs like $25, and there is no clone available that has the Wi-Fi and the right number of I/O pins and the other stuff to be able to drop in. So we've been looking at a lower cost module. We think we found one. It's about $6. It looks like it can use the same chipset, so we don't have to totally rewrite the code. It has enough I/O pins, but there's a lot of work in modifying the code from using the Wi-Fi interface to using a serial port and all the other minor changes that the hardware changes require. George, K9TRV, has been leading the effort on getting the software ported. And again, we're close. We have hardware and software that almost work together, but not quite. And once we get a couple of more things worked through, we'll be able to actually put the new hardware, the new Arduino clone module on the board. And it shouldn't take much beyond that point to have something ready for sale. So I'm hoping that by the end of the summer, before the next DCC, we'll have these available. But keep your fingers crossed, because there are a few hurdles that we have to overcome. The next thing I'd like to talk about is not really timing related, but you get there through one or two hops. Whisper Daemon and Whisper have become extremely popular for HF propagation spotting and even up on 6 meters and higher frequencies. And there are a couple of radios that have become very commonly used for that. The first are the Kiwi SDR, web SDRs, because they can not only have real-time users connected, but they can be monitoring several bands simultaneously to decode Whisper. And then about a year ago, this thing called the RX888 started appearing. And if you've been around SDRs for a long time, we used to talk about there being a software-defined radio and then finally a software radio. And the software radio was where you just had an analog to digital converter that went right into the computer. You didn't have to have any big FPGA processing or anything. And that's really what this RX888 is. It can receive DC to 60 megahertz and essentially just turn that into bits and shove it down a USB 3 port into a host computer. Phil Karn's KA9Q radio interfaces with that. So you can take one of these RX888s, which you can buy for about $160, and connect it to a modest PC running KA9Q. You can record every Whisper band that there is, as well as tune around shortwave, as well as record signals from WWV and CHU, and the thing's just loafing with dozens, even hundreds of decoders. It's really cool. But because the radio is so inexpensive and so basic, it's got a few things that it needs some help with. The first is thermal management. It gets pretty darn hot, and the heat sinking in the as-delivered version isn't great. And you can do a bunch of things to sand down the heat sinks and get better thermal conductivity, but the biggest improvement is just to use some better, fatter thermal pads on the chips so you get better contact with the case. So you need to do that if you don't want the thing to blow up. The front end, it's essentially a digital to analog, an analog to digital converter. And even though it has wide dynamic range, et cetera, it still needs some help before being exposed to the real world. So you often want to have an isolation transformer to keep common mode noise from getting out or from getting into the receiver. You may also want to have filtering to reduce broadcast bands, strong signals, and things like that. So you want to have some kind of front-end treatment. Then the 888 will also use an external 27 megahertz reference, and with that you can get extremely accurate frequency control. In order to do that, though, you need to put a tiny UFL connector, plug that pigtail into the board, drill a hole in the end plate for an SMA connector, hook it up, and then if you don't do it right and put DC on that pin, you blow up the clock chip inside and it's not good. So we need a nice interface board that makes that easier and less painful. So 3 or 4 different bits and pieces that you can put around one of these radios. Most of them would also work with the Kiwi SDR. And Paul, WB6CXC, who has a little company called Turn Island Systems, has been working with Whisper transmitters for quite a while, and he's showing off in our booth 6-band Whisper called the, I think it was called the Beacon Blaster. I think the name's changed now, but 6 Whisper frequencies simultaneously with about 1 watt each. Paul's also designed some of the stuff that we need to attain the RX 888, including the thermal heating pads, a little reference board interface that provides the kind of coupling that you need and protection against DC, and he even made a new end panel with the hole already in it for the SMA, so you don't need to drill any holes. Tapper has done, along with a lot of other people, a little antenna board with SMA connectors at each end that has a 1-to-1 transformer that simply isolates the coax shield from the radio to help reduce noise that's being brought in on the outside of the cable. So we're going to offer all those things together as a single kit to go with an RX 888. Don't know the exact cost, but it's probably going to be $40, something like that. But it will be everything you need if you buy a 888 to turn it into a very good radio. And I'll also put in a plug. Paul has developed some other filters and front-end LNAs for the 888. We don't know quite yet how they're going to be sold. He may sell them through his business, or Tapper may sell them for him. But they're very nicely designed and very reasonably priced. So if you're interested in the RX 888 or any other wideband receiver where you want to pick up the whole HS spectrum, but also have to deal with AM broadcast station noise and FM broadcast overload, Paul's got some neat stuff for that. And we'll hope that those will be available inexpensively quite soon. And beyond that, we have a couple of things in the works. I have a board that's designed, and it's actually came out of the RX 888 project, but it's 4 digital outputs from 1 input that's buffered and can take anything from like a -15 dBm signal and turn that into 4 nice clean logic outputs at anything up to 100 megahertz. And it's in the same form factor as the Gus antenna splitter, so the same case will work. We'll have those available, I think, by the end of the summer, if not sooner. And Scotty already mentioned a tiny NTP server, which I think is a really cool idea. There are lots and lots of NTP kits around. You can buy hats that will go on a Raspberry Pi and things like that. But using the Pi Zero makes it very small, and it hugely reduces the current draw. So this thing can run off of batteries for the weekend. So really, really helpful if you're doing field day and have digital stations where you need to have all the computers lined up. This will be a great thing to throw in the bag and give you timing when you're away from home. And that is about it. So happy to take any questions or turn it back to Scotty.
Who's had the question? Yes.
John, do you know the approximate cost for the NTP server, and will it have a disciplined frequency out?
The man is standing in front of you who can answer the cost. It will not have disciplined frequency. It's purely a time server.
So Wi-Fi connected time server, and we're aiming for the non-battery version under 100 and the battery backed up version 150. Thank you. So, other questions? Okay.
Okay, thanks.
Thank you. Thanks, John. Should get these back. So next up, we have Munir to come tell you everything you want to know about digital voice. And he's going to tell you whether you want to know it or not. Okay, take it away, Munir. Up and down.
Hey everyone, hear me okay? All right, so I'm Munir Salem, K6AQ. I'm going to talk a little bit about the EasyDV device. A little bit about myself, licensed since the early 2000s, original call sign being KG6AOV. Do a lot of software development. In my day job, I work for a medical device company, C and C++ development there, and a little bit of C# and other stuff as well. And then I do a lot of open source stuff as well. FreeDV and of course EasyDV being the biggest things I'm working on right now. So for those of you who aren't familiar with what FreeDV is, it's basically an open source HF digital voice mode, and it uses a codec called Codec 2. And this codec was created by David Rowe, VK5DGR. And typically people either use the FreeDV application, which you can get at freedv.org, or a hardware device such as EasyDV or the SM1000. And if you want to find out a lot more about FreeDV, you can come to our booth, 1909. Or I'm also giving a talk tomorrow in a digital modes forum at 9:15 a.m. So EasyDV is basically a handheld device. And inside that device has an ESP32 S3 microcontroller. And the nice thing about the ESP32 is it has Wi-Fi built in, but I'll talk about that more in a minute. But EasyDV supports several of the FreeDV modes, 700 D and E, 1600, as well as the ability to just do analog pass-through, so you can just treat this as like just a normal sideband microphone effectively. And it also has a battery in it, and 2,000 milliamp hour. In my experience, it typically lasts for most, if not all day. But if you happen to run out of battery while you're, say, doing like a POTO or SOTA with it, for example, then there's a USB-C on the bottom. Charge is pretty straightforward with any sort of USB brick. And I talked a little bit about the Wi-Fi support. The nice thing about the Wi-Fi support is that we can basically use that Wi-Fi support to do cat control and audio input and output with the radios, with certain radios that it supports. Right now we support the Flex 6000 series. I guess the 8000 series hopefully as well, since Flex just announced that yesterday. And the ICOM 705 as well. And then with Flex in particular, the analog audio will also route through Smart SDR. So in effect, it looks like a mode that's built into the radio already, as you can see in the screenshot up there. And Wi-Fi support also allows some certain internet connectivity features, such as reporting to our official spotting service called FreeDV Reporter. And you can go to qso.freedv.org right now and take a look at the live activity of FreeDV. But of course, you don't actually need internet to use EasyDV. It's just a nice to have thing if you do happen to have internet access wherever you are. And we also have some additional like Flex specific features. As you may know, the Flex has a spotting feature where it will actually, if you're running a program that supports it, it will actually put the call sign of the spot in the Smart SDR waterfall. And an example of that is in the water on the slide up there. And it's pretty useful if you just stepped away from the computer for a minute and you were hearing FreeDV going off in the background. You'd be able to pick up who was trying to like transmit and maybe be able to call them back. And in addition, because we spent a lot of time integrating with Flex, there's setup of the Flex support inside EasyDV is actually pretty straightforward. It's effectively you just select your radio from a list and choose save. So hopefully you guys want to buy an EasyDV. Tapper is actually selling them right now at their booth in 5009 through 5011. And if you don't happen to be able to get one during Hamvention, or if you want to buy a second one later, you can go to reach out to me. During then. My email is munir@gmail.com, or you can go on the FreeDV Discord, and my username is TheMindIsWatching, and my username on GitHub is TMIW as well. And if you have any questions, the EasyDV user guide is a really good resource to look at how to operate FreeDV, or EasyDV rather. And that's also linked on the Tapper product page for EasyDV. So I think I have a little bit of time for questions. Any questions?
Thank you. What is the advantage of using EasyDV over using just the software on the PC?
So the advantage of using EasyDV over the software is traditionally with the software, if you have to have a computer, right? So if you want to do a POTO or SOTA with EasyDV, for example, or you would just want to operate portable in general, you normally would have to carry your computer around with you, or like a laptop, and that's one more thing you got to keep charged. Of course, you got to keep this charged too, but it's a lot smaller and it takes a lot less power than a laptop, for example. So having EasyDV with you, in addition to having the software running, or even just instead of the software, means it's less stuff you got to carry around if you got to go portable. And there's a lot of people who just don't like installing this, like dealing with anything computer related, so they'd rather have something they can set up once and like just run connected to the radio pretty much.
All right, thank you.
So you could use this in a mobile setup, right?
Yeah.
Where you're probably not allowed to text while you're driving, so you can't run your laptop either. Any other questions? Okay, thank you, Munir. Okay, this is going to fall on the floor. So up next we have magnetometer. You may have to adjust the volume here for this. So I'm going to start. Okay, where'd it go? Keep hitting the wrong button. How about that one? Okay, so you're ready for audio?
Hello, I'm Hyo-min Kim, Assistant Professor of Physics at New Jersey Institute of Technology, and I'll be giving a talk about citizen science, development of a low-cost magnetometer system for coordinated space weather monitoring. This project, called Personal Space Weather Station, has been conducted as part of the Ham Radio Science Citizen Investigation, HAM-SCI, project led by Dr. Nathaniel Friesel at the University of Scranton. Listed here are the co-authors who contributed to this project. I'd like to thank many HAM-SCI members for development and installation of the instrument presented here. Particularly, I'd like to acknowledge one of the co-authors, Jules Maddy, who passed away last year. He played a crucial role in developing and testing this magnetometer. This project is funded by the 2 National Science Foundation grants as shown here. As part of Ham Radio Science Citizen Investigation HAM-SCI Personal Space Weather Station project, magnetometers have been designed to provide measurements of the geospace environment from the ground. Personal Space Weather Station magnetometer data will be combined with high-frequency radio observations to monitor large-scale current systems and ionospheric disturbances. A densely spaced magnetometer array, once established, will demonstrate their space weather monitoring capability to an unprecedented spatial extent. The primary goals of this project are, number 1, to provide a general context of geomagnetic activity during the HF experiment, 2, to estimate ionospheric currents, 3. To measure ultra-low frequency ULF waves. 4. To measure space weather-related disturbances such as dB over dt. These figures demonstrate a brief overview of the environment between the Sun and the Earth. The outflow of the solar wind from the Sun's atmosphere continuously interacts with the Earth magnetic environment and human technologies, such as Sun-Earth connection creates a unique geomagnetic field structure called magnetosphere around the Earth, as shown here. There are a variety of current systems in the magnetosphere and in ionosphere due to the coupling between the Sun and the Earth. The current system plays a crucial role in transferring energy from the Sun to the Earth. Changes in currents in the magnetosphere are projected onto the ionosphere via currents flowing along the field lines. The processes in the ionosphere are often observed on the ground. The magnetometer is one of the commonly used instruments to measure such physical processes in the magnetosphere and ionosphere. The magnetometer for our project employs a magnetic sensor RM3100 manufactured by a company P&I. This sensor utilizes the magneto-inductive sensing technology, where an inductor develops a magnetic field when a current flows through it. Alternatively, a current will flow through a circuit containing an inductor when the magnetic field through it changes. The sensor measures magnetic field strength and interaction in 3 axes and their temporal variations. This sensor features low power, low mass, small size, low noise, and large dynamic range. The resolution of approximately 5 nanotesla at the sample rate of 1 Hz is very suitable for space weather monitoring that our project is aiming for. The sensor communicates with a computer via the I2C and SPI interface protocols. The sensor itself costs only $25. The personal space weather station magnetometer system consists of 5 basic components. Local computer, in this case Raspberry Pi. B, local magnetometer support board extender. Shielded Ethernet cable. D, remote magnetometer support board extender. And E, P&I RM3100 magnetic sensor. And finally, magnetic sensor burial parts kit as just shown here in this PVC packaging. These magnetometer set is available for purchase at the Tapper store as shown in the website link here for $120. Our magnetometer system samples data every second per axis. The sensor is oriented conforming to the HEZ system, which is widely used in the space physics community. The H component points toward the local geomagnetic north in the horizontal plane, which is perpendicular to the line pointing toward the center of the Earth, defined as Z. And the E component completes the orthogonal system pointing toward the geomagnetic east. For temperature stability, it is recommended that the sensor is buried under the ground. Here, the sensor is assembled in a PVC pipe packaging. As the magnetic sensor is sensitive to electromagnetic interference, the sensor module must be located away from the metal objects and magnetic fields. Once deployed, magnetometer data from each location will be collected and stored in a central data archive. Currently, we are developing a graphic user interface, a test version is shown here where users can select date, time, and stations to view and download acquired data. The central data archive will combine magnetometer data and radio receiver data to monitor space weather in a broader context. Lastly, I'd like to show the scientific use of our magnetometer data. The plot on the left presents magnetic field and particle pressure originating from the sun as measured by a spacecraft located in the solar wind. At around 2 UT, compression of the magnetosphere due to solar wind pressure increase is shown in the gray box, which could develop into a geomagnetic storm. The plot on the left shows stacked magnetic field data obtained by the professional magnetometers run by U.S. Geological Survey, USGS, and Natural Resources Canada, NRCan, the top three plots, and the HamSci Citizen Science magnetometers, the bottom three panels, displaying almost identical responses due to the solar wind compression events as indicated in the gray box. In addition, ultra-low frequency ULF waves, one of the major means of transporting energy from the solar wind to the magnetosphere and ionosphere, are also observed as shown in the red rectangle. We can see that even the HamSci magnetometers also observed such wave events. Note that data are background removed, so you can see the variations only, and then HamSci magnetometer data are moving average every 60 seconds. Here is another example showing a phenomenon called substorm, a process through which a large-scale energy is being released from the tail side of the magnetosphere. Substorms are often associated with aurora. The plot on the left presents magnetic field and particle pressure originating from the sun as measured by a spacecraft located in the solar wind. At around 5 UT, a sudden increase in solar wind pressure is shown in the gray box, leading to a substorm. The plot on the right shows the data from the Personal Space Weather Station located in Scranton, Pennsylvania. The top panel shows Doppler shift of plus minus 1 Hertz observed by the HF receiver operating at 10 megahertz during the substorm. The bottom two panels shows magnetic field data from the HamSci magnetometer co-located with the HF receiver. The sudden deflection of the magnetic field indicates the change in the ionospheric current system during the substorm. The bottom panel shows the Fourier transform magnetic field data indicating ULF wave events around 2 millihertz. To summarize, a low-cost magnetometer has been developed for a citizen science project, HamSci Personal Space Weather Station. Data from the magnetometers are presented and compared with professional science-grade magnetometers nearby. The HamSci magnetometer successfully observed space weather-related phenomena, demonstrating that its performance is very adequate for scientific investigations. Once established, the proposed closely spaced magnetometer network will provide quantitative and qualitative measurement of the geospace environment from the ground for both scientific and operational purposes at a cost that will allow for crowdsourced data contributions. Thank you for listening.
Okay, thank you, Dr. Yeoman Kim. If you have any questions, I could attempt to answer them, but really the best way would be to come over to the Tapper booth, because right next door to the Tapper booth in 5009 in Building 5 is the Hamsci booth. And Nathaniel Frizzell is there, and he can answer lots of questions way beyond my pay grade, my ability to answer on the magnetometer. So if you want to stop by there, and don't forget, pick up a flyer for the GNU Radio Conference, which is directly preceding the DCC this fall, and a membership application if you're interested in becoming a Tapper member and supporting our fun projects. And we encourage you, too, to come by and talk to us about your project, because maybe we can manufacture yours for you or help you with prototyping or whatever we might be able to offer. So I think that's it for what we have today. We'll see you in the booth. Maybe I'll be able to talk a little better by then. Thank you.
Might be in presentation mode or extend mode. Let's try duplicate mode. Do you want it in the here? I don't need the presentation. I then you don't need a piece of hardware. You can still make use of it. All right, are you going to introduce mine? Yeah, we'll do all that. Hey, good morning, everyone. Welcome to the K4 Forum. How many of you were here last year? Wow. How about 2 years ago at the inaugural one? Is this an upgrade or what? It is, yeah. Thanks to Michael Coulter and the Dayton Hamvention crew. I'm Scott, K0MD. We asked for an extended time this year. After last year, we realized we had 2 hours of material for an hour of time. So this morning, we'll start with Eric Schwartz from Elecraft. We've given Eric 25 to 30 minutes to talk about some stuff at Elecraft and answer questions. They've got the K40 on display at the booth if you haven't seen it. I saw it at Visalia. He can tell you when he thinks it may be available, as well as software. Rick Taven. Rick, raise your hand for a second. Wave at everyone. He's got the VK4 on display that he'll show you either here or at the booth after the forum. We're going to have Eric speak, and then Bob Wilson, who everyone knows, TV Bob, will do about a 30-minute slideshow. And then based on the Groups I.O. question, someone submitted a question about how to manage receiver gain in terms of attenuation. So Rob Sherwood will give a few slides and talk about that in general. And I've heard Rob's talk many times at Contest University, and it's really good. And I've actually used his techniques. How many of you have used his techniques in your shack? Yeah, I find they work very well. So I think that'll hopefully answer the question. And then Rick Taven and Bob and Ed Munns. Ed, are you here yet? Where are you? There you are. Hey, Ed. And Dave Anderson. Dave, raise your hand. These are all four individuals who've been doing a lot of remoting with the new K4 to K4. So they'll come up. And I'm not going to introduce everyone again. I'm going to step off the stage now, turn it over to Eric. And welcome, Eric.
Can I fold this down, Scott? I have some notes. Actually, it's a voluminous list that N6 TV sent for questions to answer. So Bob ambushed me on the way out in the airplane. We flew out together, going out from California. So let me get up. I may have to put my reading glasses on because he gave me so much it barely fits on the screen here. Thank you, Scott, by the way, for organizing this and getting us all out here. Can you guys hear me okay? I'll get it up here, get my volume up. I'm recovering from the booth just for the first couple hours this morning. I can't imagine what the throat's going to be like later on tonight. So excuse me, A, if I'm talking too fast, because I'm on way too much coffee. If anybody knows K6XX, I can't compare to him because he carries a large thermos that he drinks the whole thing out of the whole time. But let me bring up the screen here so I can see what I was going to do. Just a moment. Just a second. I'm sorry? I know. No, I had it. I can enlarge it on here. But I can almost. I still can't read without my reading glasses. So excuse me if I'm using reading glasses. But before I cover that, just briefly, and I'm going to mostly answer questions from you guys. That's why I'm here. If you can't get it in the booth, you can get it here or catch me afterwards there. Of course. First thing in the show, it's quite a big a crush in there right now. We're wall to wall, but it'll get better, as people spread out. As the rain gets a little less, right now everybody's forced inside, so that happens. For those of you, just a couple of questions here. How many K4 owners do we have in the audience? Whoa, wow. How many of you are trying the new beta remote software out there? You having fun? Working. Hey, Dave, I see you're up and running now. That's good. And so I want to talk some more when we have a chance afterwards. Come by. I know you're talking here too. Great. And I've also talked to a few of your other guys that probably are sitting next to you, and I can't focus out there right now. But we've got that out in the public now, so not just the early field testers like TV Bob and company. And by the way, I've got to get you on that list. I still owe you to get early on that, so bug me on that because I won't forget. But the beta stuff is of course, working pretty well for you guys. Are you pretty happy so far? I mean, a lot of the stuff that you guys have been hearing about, little glitches and stuff, we've actually already addressed. We are holding out releasing another beta until we actually finish the voice DVR code. That's the last big piece that we were missing. And I wanted to let the engineers do that versus getting interrupted by continual doing intermittent releases. That adds a couple of weeks to it. You'll see another beta coming out with DVR, and you'll also see any little glitches that showed up that we're dealing with on that. It's quite solid as far as I've seen it so far. So they've been working pretty nonstop. If you for the guys that got the first beta when something was not quite right, before beta 2 came out, you notice it came out really quick. Well, that was sort of all hands on deck. They just immediately take that very seriously when something like that happens. So that's sort of our ethos inside the company. We try to, obviously, we can't do it all instantly every time, but that was one we wanted to make sure we covered for you guys. We definitely have seen the impact on K4 orders. There's actually surprisingly, I didn't expect people ordering 2 at a time, but they're doing that, believe. I'm not kidding. I guess if you have a north and a south location or something, that works well when you bounce back and forth. So one thing that's cool about that is you don't have to, when you have a K4 controlling another K4, or a K40 in that case. I'm getting sound effects now with me too. Can you hear me above the QRN, the sound system? Okay. Hopefully the mic's not picking that up too much. It's loud up here. When you're hooked up cable-wise to a K4, like for your home station, and you're controlling your friend's station or another remote like Dave's, you don't have to change your cabling at all. Basically, it thinks they're talking locally, but it's actually the remote station. So that was one of the key things. K30 does the same thing. So you basically can hook up to that. It'll act the same way if you have local logging going on and or data mode programs with sound card interface. That's all built into those products. So we'll talk a little more about that. I'll walk through some of Bob's questions. I'm going to, Bob, for your benefit, they're going to be compressed. I'm compressing some of them, so you're not going to hear me addressing them individually in some cases. So the question is, Bob was asking, when will the K40 VPod VK4 come out? It's real easy because it's about the same question. And for those of you at home who are watching this on streaming and stuff, I'm being very cautious here because we have both software and hardware stuff that can delay us. So this is not a hard date on anything. I generally am saying, and I can beat this or I could be later than this, but I'm trying to, obviously trying to beat it. I'm saying late summer, fall for all those items. K40, the issues are, we have a little bit of software that's different in it because we don't have a DSP in it like we have K4 on the K4 client. So we're using a PIC32 to translate some of the code for local side tone, voice DVRs, things like that locally. But it's not a horrendous amount, but we've got our key firmware engineer, Paul Safran, is doing that. He's great, so he's cranking through that right now. We're turning the circuit board for the I/O on that right now. The unit I have in the show for the K40 is just connectors on the back, so you can see physically what it looks like in a screen display. If you punch the buttons, it doesn't do anything. It's a static display on it. But it actually shows you the actual sheet metal, the size of the box, and the rough weight too. It's pretty accurate on that without the batteries. We can actually support batteries for couch portable, I think, or poolside portable if you want to operate that way too. There's a lithium-ion battery pack you can get for it. But anyway, getting back to those, it's in that time frame. On the K40, it's those items. On the case of VK4, Scott, who does most of my UI on that, and actually is responsible for the Windows, this virtual K4, has been working on all the stuff that was necessary for the beta for the K4s. So he does UI on both places, so that's why that was on hold pretty much while that's happening. He's now transitioning back, for the most part, back to that. I'm going to jump ahead a little bit for iOS. For those of you who've used Marcus's software, anybody who've used that out there? He's working on the K4 stuff right now for iOS, iPad OS, and Mac. He's actually, we had to do some changes for Apple because they don't like the particular type of encryption we were using for our regular encryption, and so we had to give him an alternate. That's in there now. And so a way you can actually turn off encryption on the data and PAN adapter, voice and PAN adapter side, and then they're happy with that. and then they do secure password stuff. They didn't like having pre-assigned passwords for some reason. Don't get me started on that. But in any case, they has that working. He's actually streaming pan adapters, streaming audio and all the control data. And now he's got his standard modules, because those of you who used his interface, I'm sure you'll see a lot of the same interface that he's already got. He's integrating that together. I don't have a schedule from him. I wanted to try to get that, but he and I couldn't connect beforehand to see when he's going to be popping that out. But that'll be sold by him, not us, just so you know that out there. When I travel, I'm on iOS stuff. I'm at home, I've got Windows and Linux and everything else. And so that's why you see that bifurcation on that going. But my guess is probably in the same time frame as the other stuff. VPod is our virtual K-Pod. It's not an officially announced product, but what we're working on for the software I/O guys is how do you get local CW key and local CW monitor side tone on a Windows app. You don't want to run that on a Windows. And so the VPod, we're going to have integrated CW input. What Rick is demoing actually is one of our hacked K-Pods. That's not the way we want to run it, because you can actually put a paddle in the back of his K-Pod and send CW. The K-Pod only has a little piezo transducer, so that isn't the best thing for CW. It will match your side tone, but it's very weak. You can barely hear it in a crowded room. And of course, it's not mixing in with audio from your headphones or speakers on receive. So the VPod, the proper one, will be adding the ability for that all built in, plug your headphones, plug your microphone into it for a software app. So that could be our stuff, Marcus's, whatever. And also has built-in 2 COM ports and a sound card, all over one USB cable going back to your computer, whether it's a tablet or PC, desktop, that kind of stuff. And that'll be into the summer timeframe also. But right after we finish the layout stuff on the K40 for the I/O board, that gets in gear. That's pretty well defined. We've already got the CW stuff working, because that's what we prototyped on the basic K-Pod. You can hack that in to play with it. We will even loan you the code if you want to play with it. You just take out 3 transistors on the board and jump her across on the output. There's a little output jack on the back of the K-Pods that most people don't use for turning relays on or whatever you want to do. You can make that an input, which is sort of cool. But don't ask en masse for it right now, because we're tied up getting, of course, all the K4 stuff going first. Am I going too fast for you guys, or is this okay? Okay. K4 HD, roughly in the same time frame. That one has been behind getting all this other stuff done, but we've actually got the board laid out for it on the latest version, and I'm getting parts in for that right now. And I was a little bit delayed because we got tied up on some of the K40 stuff, and it's just logistics getting that stuff all in at the same time. That's the one that has basically a K4 mixing front end, a K3, excuse me, and some crystal filters you can select. You can switch it in real time on your K4D. You have to have a K4D, by the way. You have to have upgraded to that before you can go to this. And then you can actually switch that on and off as needed. So if you don't need the crystal filters, you want the really nice sound that you get from a direct sampling receive, you get that. You go through the crystal filters, will be a little effect, because obviously they have their effect on the audio through the system. But you can also get the additional blocking dynamic range that provides, because that picks up another 8 to 10 dB of that in those really extreme cases where you've got somebody right on top of you that lives about a block away. S9 plus 20 guys, S9 plus 40 guys aren't going to usually cause you a problem. It's like right co-located is the issue usually. Field Day and actually de-expeditions on K4s haven't been an issue, interestingly enough, the way they operate. But we had the Clipperton Island guys had those and stuff, so it's been doing great for that environment. So most of the folks have been pretty comfortable. But that said, people like me want to have that button to push sometimes too, as you might. So we're keeping that going too. Let's see. Adaptive pre-distortion is not something we've actually ever officially announced. Of course, people see a jack on the back for input on that. We plan to do something in the future. I'm not going to promise it. I'm part of the ARRL Clear Speech group, so I'm obviously motivated to do it since my name's on that. But I'm not going to announce a date for it, because we've got to get this other stuff out first. We believe we have the processing power for what we want to do on an implementation inside the K4 in terms of the DSP and transmit. And we've got the feedback paths for all of the sensing on stuff in terms of doing pre-distortion on sideband. But I don't have any software development in place right now, because we got to get these other things out the door. So watch for me in the fall to start, or in the late part of the year, talking about that more actively in terms of a schedule. And by the way, we have some people see that I have an output on the back of the KPA 1500, and some people actually use that with some of the Anon stuff, the pre-distortion. We won't be using exactly that algorithm, because that's probably overkill for what we need to get. But of course, Warren did a great job with that for their stuff, but that's not practical in our environment or like ICOM's environment, so that we're doing it differently, so, as they did. but it'll be significant. So I think when we do that, it'll be real nice. Let's see, what else do we got here? Yeah, it does not require a KPA 1500, by the way, to do active pre-distortion. You can get that pickup inside the radio, so that's not a problem. I'm just looking at some of Bob's questions here. And I honestly don't know. He's asking about when are we going to introduce sort of simple missing features such as gen coverage button, mem button, and scan button. I don't know, because I haven't had a chance to ask Wayne that, so I apologize on that. That's not actually Wayne doing it, but he's been involved in some of the definition on that, so go through too. Transverter option follows the HD option. I'm not going to commit on that right now. I actually have a circuit board laid out for it, but I don't have the engineering bandwidth to bring that out in parallel. I'm sorry? I can't hear you, I'm sorry. I'm shooting for 2 meters plus 440, but until I have that working, I'm not going to promise it. That's actually laid out in the board that way, but I want to make sure that it's actually going to work. So
Eric, I have a remote microphone if people have questions, and for the live stream audience, it would be helpful
Yeah.
for them to hear the questions. So we'll halt Bob's questions.
yeah, I'm at the end
until
of
he's
his
got a
list,
mic.
so actually I'm going to switch and let you guys ask questions. That's easier.
Just raise your hand and I'll bring you a
And I
mic.
can take my glasses off too because I don't have to read anything. I can't announce anything on that right now.
He was asking about some kind of subtraction for noise reduction, spectral
Yes.
subtraction.
And we've talked about that in the past, but I can't promise that right now for a couple just logistic
Any questions?
reasons. Yeah.
Raise
Not that
your
I'm not
hand.
going to do it, but I just don't want to promise it and get myself in trouble.
Ed, okay. No? Okay.
Boy,
Any
we
other
quieted everybody down.
questions? Wow.
This-
Well, Bob
there's one over here.
anticipated them all. Okay, we have one.
I got
Here.
some.
Where's that?
Over there.
Here? All right, I'll pass it down.
And that way they can hear you on the live stream, I guess, so that comes out.
Is the DVR function coming up on the beta recorded in your remote K4? So, or at the server K4. So, in other words, if new operator comes in, whose DVR is he
I
going to be using?
believe and I could, please don't, well, you're going to quote me on this because I'm obviously being recorded, but that's always dangerous. I believe it is per user because we have different voices. And that's the way it was last described to me by the guys, I believe, implementing it. They may also, I think there's also a way to technically use it from the server, but I'm not positive if that's going to be available or not.
Yeah. By the way, we've really loved our
The question was for DVR on whether where the audio is going to be stored. And I think that's the way it would work generally, but obviously there's probably a way of making it work on the server too if we wanted to.
Yeah, we really loved our K4 remote, but the worst part is trying to figure out how to share it. So as soon as you get a sharing application up, we'd love to use one.
A sharing application in what sense?
In other words, multiple guys with K4s want to use the K4 in the server side. So.
Oh, okay. Well, actually, you can do that. It actually supports up to 4 users,
Right,
but you have to figure out a way to coordinate
that-
between each other, right?
Yeah, that generates contention within the group. So.
Yeah, you sort of have to have polite operators with each other. It's not for general public use.
Okay, there's someone on the other side of the room. Just raise your hand and I'll be over.
I see the microphone moving here.
Yeah. Okay, where are we again with the question? Okay, good. Yeah, thank you. Thank you.
Okay.
Thanks for everything that you've done with the K4 remote. It's awesome. I've had a chance to play with it, both client and server.
Cool. Okay.
Haven't found any bugs, but I haven't done a lot with it either. So, multifaceted question. K40 prototype, is there a working prototype yet?
No. Yeah, the K40 prototype, in essence, is the K4 to K4 stuff we're doing from a software standpoint. The major functional difference on the K40 itself is, as I mentioned earlier, there's no DSP in it because we don't really need that. We're transferring a lot of that same, it's all written in C, so the DSP code that runs in the K4, a lot of that logically gets transferred over to that chip. We're doing that right now. And that really is the main software difference. Obviously, there's some other physical differences inside, but from a logical standpoint, it's all stuff we're already doing in the K4. So that has to be done. The other major issue in terms of getting it out for production purposes, we just finished the I/O board, or just finishing it right now. What we have in the show is just got the connectors on, so you could see it going out the back in a static display. It's using the same single board computer. That one, we just want to make sure that's all correct. There'll probably be at least one turn on that board. That's why I'm quoting more end of the summer, fall time frame, but I may beat that if everything goes to plan. The then I shouldn't say me, we, because I'm not coding it myself on this one, but they won't let me code that. I used to do that years ago. You keep me away from that now. But once that comes up, it comes up pretty quickly because all of the main stuff we've done for remote is the same. UI, that doesn't change. Anything you see on a K4 to K4, you'll see on this screen. It's exact same front panel on the K4.0. Has the ability with a built-in 2 virtual COM ports and sound card over that USB connection to an external laptop or computer. So you've got the same kind of interface you have on a K4 for logging, digital modes, all one cable. One note about the K4.0 is powering it, you have 2 ways. We've got APP connectors if you have that standard in your shack, like we use for the radios, or you can use a USB-C power-only connector on the back to hook up like a 30-watt iPad, for instance, or whatever, from Anchor or one of these other third parties charger, and that will both charge internal batteries if you've got them and run the unit, so you don't have to carry a big block of power supply around with you to operate it. So those are cheap and available everywhere. I don't have to worry about getting those, which is nice. So,
yes, thank you. Do you have chipsets selected, and do you foresee any supply chain issues for what you've selected?
Not terribly on the K4.0, no. I mean, surprises are every week, so you never know when that's going to happen. To be honest, where the supply chain's at right now is I'd say it's running at 80 to 85% of where it used to be, maybe. But I'm not seeing what I had during COVID, which was horrendous, right? Mm-hmm. So we generally have second sources for most of what we're working with there. The SBCs, I'm getting quotes anywhere, and it's just typical production quotes of 8 to 12 week delivery. That's normal because those are being built by ASUS. ASUS owns it. It's Aeon, A-E-O-N, I think it was. I can't keep track where these companies get bought by other companies, but they build it out of Taiwan on that. So almost all the SBCs are coming from there in that area of the world. The displays, U.S. company, I wouldn't be surprised they're getting them built offshore. They stock a fair amount, so we're in pretty good shape on them. We use those in the K4 anyway, so I'm just increasing quantity on that. So I haven't had any surprises yet. Microchip is not always my favorites for delivery, but we use that same chip, I believe, in this one elsewhere in the radios, so we usually have a flow going. So the answer is anything can happen.
Sure.
I don't have anything right now that's jumped out at me when we've been talking to our suppliers, so I don't think it's going to kill me. Sheet metal is all done locally in California. We have 2 good vendors, and the prototype stuff you see here only have 1 or 2 things we want to change on it. So I've got enough for my initial prototype runs, but not fab. But that'll be done well before other stuff comes in.
Then the final question, do you think you're going to hit the 2K price range?
That's the target. I'm not going to say until I'm there,
Okay.
until I've actually got stuff all in and quoted.
Thank you.
My goal is always to beat that, but there you go.
Oh, okay. Okay, thanks, Howard. Other questions? Anyone else? Okay. Okay. Easy question, good. We'll let you be the last question.
This is really a low priority thing. Nobody cares.
That's okay.
The APP implementation on the K3S and whatnot, it was not submerged in the panel. So if you put a cable on, you can actually use the APP cotter pin to lock it on there so it will not come off. You move the radio, the power cable could come off. The K4 is not like that. It's buried deeper. You cannot access the Anderson hole to put in a pin to lock them together. So you pull the radio on your desk and it can go, and your power cable's half off or
I see
pulls
what you're
off.
saying. Yeah.
Can you make it stick out far enough on the
K4.0?
K4.0 so
I'll have to go
you
look
can
at
put the cotter pin in?
Come by and take a look at the one we've got so you can see if it does it. I'm not sure. I haven't looked at it, so I'm not sure where
Yeah,
it
I
is
did
on
talk
there.
to one of your engineers on the phone a year ago, but
They probably didn't know at that time. The person that did it actually, I'd have to ask him, but I can look at it physically. I mean,
you
it's
can't.
right
So
here.
you can't put a pin in the K4 because it's buried too far
I
in the
didn't
panel.
realize. Actually, to some extent, I get 2 groups of people that want me to bury it all the way in.
I understand.
Because they don't want to plug it offset, right? One side. Usually, that doesn't hurt the radio, but it might hurt your cable if you short it out.
Unless somebody has right angle AP,
And then you got then that's an issue. You want to lock it in. That's a good point. Especially for portable use. Though actually, for portable use, you probably just use the USB-C with your wall wart if you're worried about that. But that's pretty standard. But I'll take a look. If you want, come by the case and we can show it to me. I'm pretty sure I know which the pinhole you're talking about.
Yeah.
I have not looked at the back of the K40, but that may be an area we have some opportunity to move it around.
All right, thank you.
And there's a hook coming for me yet? I know I was pretty short here, so I wasn't trying to make it too long here. Come by the booth, grab me whenever you want, or any of the other guys. Wayne's pretty surrounded on KH1 stuff, but I can answer I have all the remote stuff myself. Bob Wolbert's quite familiar with it. He's over with the amplifiers, but he also has a K4 there. All of them are on the network. We can bring up and control. We've got my station. We've got Dick K6KR station up in Whidbey Island. We've got one of my engineers, Brandon. Well, he may be developing on it, so I don't know. You may not be able to connect. You'll hear funny stuff if he's got different code on it. But we can get to several stations on there, which is nice. We can even control inside the booth and talk about that. But I can answer questions on the remote. I've been sort of the manager for the remote project for a long time. So,
well, let's thank Eric for being here today. Eric,
okay.
Thanks for taking time.
Thanks a lot, guys.
Before we transition to Bob for a moment, I just need to see, is Rob Sherwood here yet? Rob, are you here? I know he's running between forums, so he'll be here in just a minute. We are being live streamed. I understand this will be recorded, but it's not recorded instantly. It'll be uploaded outside of Hamvention because of the Wi-Fi issues. So anyway, Bob's going to take off here in a minute, and then if there's any time left between Bob and Rob, we'll do some Q&A as well. Thanks.
Will it work when we turn it back on? No. So far, there's a power button. I see a screen. They told me there'd be no password. Is it coming up on the monitor yet? Okay. Admin sign in, no password. Hey. All right. I see it here. Are you guys seeing anything on the monitor? No. Help, please. I signed in. I see it, the screen here. I just need to activate the HDMI somehow. It's plugged in. I think maybe you have to turn on the TVs because they powered down. I think they turned themselves off. That's looking better. Still, oh, come on, draw, show. Shoot. Eric messed me up. It's all Eric's fault. Added a few new slides, and we'll talk about that. The norm switch is your friend. It's the number one thing you should learn how to use on the radio because you turn to a new mode or a new band and all of a sudden the filters have changed and doesn't sound right. Just hold down that filter knob. Anything in yellow is hold, and that normalizes the filter for the current mode of that receiver. Number two is as the radio comes from Elecraft, it probably says speakers external 1, which can defeat some of the diversity reception and dual watch capability. So if you have no speaker connected, you can safely set that to 2. If you do plug a cable in the speaker's jack and it's a stereo cable, even if there's just one speaker connected to it, set it to 2 and then you can get the stereo separation. And remember, you don't have to, like other radios, plug a headphone in and unplug a headphone to mute the speakers and unmute the speakers. It's completely unnecessary with the K3 to wear out your headphone jacks, either the front or the rear. From the factory, the PF3 button on the front panel, when you hold it down, it toggles the speakers on and off when headphones are plugged in. So keep in mind you can save all the wear and tear on your speaker jacks by using that PF3 key. There is a built-in manual. It's being updated with every release. Except for programming information, it has the latest stuff. I do hope they put the programming information in the radio too at some point. That'd make it easier to do macros. But if you find it awkward to use the panel in the radio, that link I've got there, HTML file on the web, the exact same help text. You can open it with any browser at anywhere within internet, and you can use your Find facility and view the help text there to look something up instead of trying to use the radio. So both are available, but real quick, to get the help text, as you guys probably know by now, you hit the question mark button, and then you can hit this little magnifying glass, which is a search button. You can type in the search term you're looking for, like IIR, what's that? And then tap the enter key, and you can then page through the help text. It highlights all the places, and use the arrow key to jump from spot to spot. And this magic button here, which is not totally obvious what it does, well, if you click that button, it takes the full screen. It leaves all the buttons you need for the help text, but it takes the full screen. So it's a little easier to read on the screen, and you can just tap that same button again if you want. Don't forget, like if you go into the menu and you've just did something, or you can't remember what you just changed in the menu, and you want to see where you were, if you open up the help text and then tap the last control button, it'll jump to that part of the help text. So you'll know, oh, that's the menu I was just messing with. So tip number 4 has to do with this default factory, the default settings that come from the factory on the scope. You really don't want your waterfall display to look like this, and you might find it looks like this when you first turn on the radio with the factory defaults. What's wrong with this display is that there isn't enough vertical scale, and all you're seeing is a bunch of noise in the lower part of the waterfall instead of very clear distinction between signals and nothing. So there's a lot of display settings. I'm going to go through some of them now that can help with that. The main problem with that prior display was that the vertical scale wasn't showing enough range. There was only a couple of S units. I think it's like 30 dB, what's that, 5 S units worth of vertical access, which isn't enough because there's a huge difference in signals in most locations. So the first thing I recommend everyone does is change the display scale, and I'll show you the buttons that how to do that, to at least 80 dB of range, and then things get more clean. There's a ref level feature of the K4. It's kind of a unique feature of the K4 that automatically trims the grass, automatically sets the noise level at the bottom of the screen. And that only works if you set ref level to auto. If you happen to tap it and toggle it to man, you can toggle it back to auto mode. The default offset for the where it automatically sets that offset is -2, which tends to put too much noise in the display, so or maybe too little noise. So I tend to bump that up to 4, and I recommend trying that to see how you like it. The screenshots here were taken with these settings. And then, so here's well, let me go back up here. The display mode that I find most useful is called Fix 2. And there's no smearing of the waterfall. The cursors move instead of the whole waterfall moving. I mean, these folks who say, no, I'm going to use track mode. I don't want that cursor in the center of the screen all the time. To me, that's kind of like reading a newspaper by holding your head still and making the newspaper go up and down, which seems kind of silly to me. So I like to move the cursors, or move your eyes, if you will, so you can point and shoot to anywhere on the screen without everything jumping around. So Fix 2 scrolls half a page width of span every time you get to the edge, and that works well for me in most cases. Then when you go back the other direction, the left edge is where it was before. Some of these slide modes they added are fancy, but they tend to smear when you get to the edges. You can experiment with them, but I prefer the Fix 2 mode because of the way it messes with the edges if you don't do that. I think you'll find the 40 kilohertz span is about optimal for CW, and maybe about 100 kilohertz on phone. You can try experimenting with that, but don't make it too narrow. Maybe 20 when the band's really crowded on CW is good. And I'll show you how to set the RIT knob so you can use it to slide the display around, because often you end up with the display showing out of band stuff, and you want to set the bottom of the band at the left edge of the screen, and you can use the offset knob or RIT knob to do that. And once you get everything set perfectly, then you can just double tap the A to B button. A double tap is going to say copy all from pan A, all of its span settings and everything, to the subreceiver, and that way when you hit the A/B button, the whole display doesn't change on you. It looks exactly the same. The only thing that moves is the cursors. All right. So, by the way, if you do have a question real quick, you can raise your hand. So I talked about the display scale. It's very easy. You tap the display button there at the bottom, and then you hold down, everything in yellow you hold down for like 1 second or 2 seconds until things change. So you hold down the scale button, and then you can rotate this VFOA knob. When you see that little symbol, it looks like a curly Q there, that just means the VFOA knob is your adjustment. So when you get that, anytime you see that on the screen anywhere, it means turn the VFOA knob and it's going to adjust things. And then you can press the plus and minus buttons, but that's a lot slower than just rotating the knob. set the scale to 80, tap display again to dismiss. The fix to thing is over there in that button. You have to keep tapping that button. Each time you tap it, it cycles to a different mode, like fixed 1, fixed 2, slide 1, slide 2, static, fixed, or something else, track. So just keep tapping it until you get to fix 2, and if you hold it down too long and your screen locks up, well, that's because it says freeze, and that's what it's supposed to do. So don't worry about freezing your screen. Again, you can set the span by tapping the span button and then rotating the VFOA knob, and that will change the width of your display, the span of the scope. So I mentioned before how to use that RIT knob when you're not using RIT. You can go into the menu and set this function here until you rotate the VFOA knob until you get down to this setting, RIT knob alternate function, tap your unlock, and then you can hit the plus and minus arrows, up and down arrows, until it says pan center. That means center. I want the RIT knob to center, change the center frequency of the display, which moves the whole edges. So once RIT is, yes? You can still use RIT. No, if you do RIT up-down commands on the command interface, when the RIT is off, it will actually do the pan. It will probably move the center of the span. Yes, it behaves just like the RIT knob. So if you use RU or RRD, I think it would actually change your display. Let me think about that a second. I know you can clear the RIT, and that won't do any issue. I'll have to experiment with that. We can probably try it on Rick's VK4 or out at the booth. Good question. I'm pretty sure I have this set all the time, and I don't see the display move when I have RIT on, and it does. I haven't tried bumping the RIT. Oh, that's why. My logging software, when I move the logging software up or down, it turns the RIT on for me before it tries to do the up-down. So RT1 semicolon RU, then you're never having a problem because it's do it with the software and it does 2 commands and it takes care of it. Good question. Thank you. Tip number 5 is really important. This is probably the #1 tip I want everybody to learn if they haven't figured out how to use the quick memories yet. This is the most useful function of the radio. Other radios don't have this feature, so it's kind of unique. And to me, it's the most helpful feature on the radio. Once you get all your filters and scopes set just the edges just the way you want it for that mode, go ahead and hit the store button and then hit the M1 button. I like to use M1 for CW, M2 for sideband, and M3 for RIDI, and M4 for FT8. The order they were invented is kind of my logic on that. Then once you've stored it, that's a per band quick memory. Doesn't interfere with voice memories. Those are totally different. If you just tap the button, it plays the CW or voice memory. But if you hit recall first and then M1 to 4, it's going to recall that per band quick memory. And I never change modes by, tapping mode and then rotating the VFO knob to move up to the phone band and then tapping mode and going all the way back down to the CW knob. That's really old-fashioned thinking. You don't need to use the radio that way. Once you've got all 4 modes programmed on all your bands, then all you have to do to switch modes is go recall M1 and bam, you're on CW or well, go ahead. Yes, you can also do the same thing on a K-Pod button. You can program F1 to F4 on your K-Pod to do the equivalent of tapping recall and tapping M1. Like a SW, I don't know, 134 or something is like the recall button. SW17 is M1. You might need to put a pause between them because if you hit recall and M1 too fast, it does take a while for all the memory screen to come up and draw, and then you can hit M1 and the memory screen goes away. So don't do it too fast. Put a little delay in the command and then recall M1 with 1 command, or a logging macro can do the same thing. So that's my favorite way of changing modes, and it's the #1 thing to learn how to use in the K4, in my opinion, to make it much easier. You just switch to the FT8 frequency and go. Recall M4, I'm on the FT8. The scope's real narrow. I've got both VFOs displayed. It's a #1 feature to learn. Here's a example of how to program the antenna configuration. This is covered in the new owner's setup checklist. If you tap the TX button and then you tap the antenna button or antenna config, you're going to see this screen right here. and it lists all of your antennas. And the same thing would happen if you tap the antenna button. You don't want to see and then have to double tap to cycle through your antennas. And we're going to talk about that in a second. But this is how you would rename your antennas. You see the little yellow label at the bottom. I have it labeled dummy. If you hold down that button, then you can edit the labels on all your antennas. You can put Yagi on antenna 1 and dipole on antenna 2 and dummy on antenna 3, for example. And this is how you relabel those antennas. And then once you've got all your antennas labeled the way you want it, I recommend you hit main RX and display all will be highlighted by default. And that means every time you press the receive antenna button or switch, it's going to display this antenna screen instead of actually switching antennas for you like the K3 used to do. So once you get all your antennas labeled and everything, you don't need to see the antenna display come up anymore. Change this to use subset and only check the antennas that you are going to have connected. And you never need to check antenna 1 if that's your only transmit antenna. Check that box over on the right that says equal TX antenna. That way the K4 doesn't have duplicate antennas in the cycle that goes through every time you tip the antenna button. So that's the best way to do it. That equal opposite TX antenna is unfortunately not implemented yet. Someday I hope they'll do that. But once you've set it up for the subreceiver, again you tap main RX and antenna config and you check those boxes. Once you set for the main, you also want the sub antenna switch to cycle through your antennas quickly. So tap sub RX and do the same thing. Check exactly the same boxes on the sub X. See in the upper left there it says sub ant switch. This dialog is telling you what the sub ant switch will do. So that means if you hold it down the receive antenna, which is the sub ant switch, either it's going to display all your antennas and then make you tap something, or it's going to just use a subset of antennas and cycle through every one in the list. So those are the most useful things to do once you get all your antennas named. And then you can just tap or hold down the sub antenna switch and it'll just cycle through your receive antennas just like the K3 would. Bipolar and EFHW in the screen, I want to change it. How do I rename my antennas? You go back to the main RX intent config and you temporarily set it to display all. And now when you hit the antenna button, the naming thing comes up and you can name your antennas. So which antenna am I using? This is a very important thing to learn on the K4, and that is that there are 3 antenna displays. The one on the left, whether you have dual watch on or not, I have both, dual display, I have pan A plus B set here. But if you just have pan A set, the same thing applies. You always have these antenna labels at the top. The one on the left is what the receiver A is using, or the main receiver. The one in the middle is your transmit antenna, and that'll always be in a different color. And then the one on the right is the one that the subreceiver is using. And as you tap or cycle through either main antenna or the sub antenna or the main RX antenna, all of those will change. You need to keep your eye on those. If you say, well, I'm not hearing anything. And if you want to change something on both the LCD and the external monitor, you can tap that ampersand between LCD and EXT, and then you change your setting. Like if you wanted both to have both displays A and B, pan A and B on both the internal monitor and the external monitor, kind of like you see here, then you would tap those buttons first to say what you want to change, and then the button below it that says pan equals A plus B, every time you tap that, it'll cycle between pan equals A plus B, pan equals A, and pan equals B. So if you want just pan A on the LCD and pan B on the external, and remember you don't have to turn the subreceiver on to see the VFOB at all settings, assuming they're on the same band. You can tap LCD, set it to pan A, and then untap that and tap EXT only and set that to pan B. What about the A and B to the right of that? Well, those are settings that affect the main or the subreceiver, and it's generally if you want to have, for example, a different scale or a different span on the pan B display than you have on the pan A display, you just tap the one you want to change, and then you rotate the VFOA knob to change it. So to me, it's very intuitive, but a lot of people get confused by it. Just try things. You know, you're not going to break the radio. To tap the buttons and turn the display. Remember, you can always take a backup and restore it if you mess everything up. All right, this is tips for CW operators like me. The factory default is 600 hertz. To me, that's way too high a pitch, and it makes the static of the band noise, which follows, the passband follows your pitch control, as it should. You want the center of your passband to match your pitch. So I find it kind of harsh to listen to, so I would recommend turning it down to 0.50, which is 500 hertz, or 0.45. I think you'll hear a much more pleasing sound out of the passband and its default filters, unless you're used to the 600 hertz tone. If you are using paddles connected to the K4 to do the CW sending as opposed to an external keyer, the factory default, in my opinion, has the weighting set much too high. The keying's too heavy. And so I believe in perfectly timed CW, so I like to set that back to 1.0. That's not the default of the K4. And of course, this only applies to keying done by the paddles or by KY commands such as the internal CW memories. And then there's this cool menu setting for the RX CW IIR filters. And if you turn that to on, then anytime you narrow the bandwidth to 200 hertz or below, you're going to get very sharp skirts. And it really helps pull out the weak ones as well as the APF, which I'm going to talk about next. But turn that on, and you might not see much different. You'll hear a big difference if you cycle it on and off while you have the 200 hertz or lower bandwidth set. So here's another tip, sub-tip of that is if you've got a really weak signal you want to pull out, I wouldn't try using noise reduction or noise blanker to do that. I would try first using the audio peaking filter. And I do recommend setting its bandwidth to 50 hertz. The default is 30 hertz. And unfortunately, it's saving the bandwidth per band and per VFO. So you kind of run through all the bands in both VFOs and set the bandwidth to 50 hertz. And you may find that after you reboot or install a new version, that everything got set back to 30 hertz, so you're going to have to do it again. I did post a big macro string that you could send to the K4 by Telnet, and it would go through all the bands and set the bandwidth to 50 hertz. It works best if your filter is an even, or your pitch is an even number based on 50 hertz. So 500 hertz pitch is great. It'll be centered on the APF 450, but if you have it like 470, then the APF will not quite be centered. It'll be down at 450 or something, and it won't work as well. So if you use an increment of 50 hertz on the pass to it, and that is to send this macro string, put it on a K-pod, and AP/ means toggle whatever the setting is, and AP $ means toggle it on the subreceiver too. I want both main and subreceiver to do the same thing at the same time. Usually I have both receivers on the same band. So you can either hold down that button to toggle the APF on and off. That's right, the other menu just sets the bandwidth. But holding it down is slow, and when a weak one calls, you want it to be fast. So I would put this command on a K-pod switch, a single tap of that, or put it in your logger macro. If you're using N1MM software, you can just put any command you want into a logger macro and send it to the radio's COM port, and it'll instantly toggle your APF on and off. It's one of my favorite features for copying the weak ones on CW is toggling the APF on, so try that. Talking about N1MM, the first time it can do a good job keying CW over the USB cable, but this is in my new owner setup checklist. The first time you connect the USB cable from times, how many times you tune around or you turn on your radio or you plug something in and you hear da-da-da-da-da being sent by your radio. Okay, that's because you didn't change these options or they got reset to their defaults. Be careful when you plug a USB cable from the K4 and you move it around to a different USB port on your PC. It'll often change the COM port number and reset all these settings to the default. So it's very important to turn off those two default options. You want to uncheck serial enumerator and disable modem control at startup. That should be the only box, and you do need to check that. And that prevents Windows from going out and seeing if the K4 is a serial mouse, which it is not, and poking the RTS and DTR pins, and then it won't key your radio when Windows boots up. There's some other subtleties, but make sure you do that on both COM ports. Because remember, you get two virtual COM ports when you plug in the USB cable. All the other default settings are fine. So now that you've turned off those options so your radio can't be keyed by Windows, now you can turn on these options in the menu And if you're using logging software like N1MM, this is a really convenient way to key the radio with the software alone over the USB cable. You don't need a WIN key, you don't need an outboard keyer. You use paddles in the back of the radio for your keyer, and you use the logging software to send CW on these 2 pins of the virtual port. And how do you enable that in N1MM? I guess this is going to be kind of hard for you guys to read up there, but I've set the instead of controlling the radio by COM port, you can control a K4 by Ethernet, by its address. Its host name is going to be, you can put in the IP address, the numerical one in the menu, but that can change from time to time depending on your router and so on. So instead, you can always put in K4-SN and your 5-digit serial number, .local, :9200. That's what I'm entered in that yellow box there under the IP address. You do have to set the port to TCP. By the way, this is also supported by dxlog.net. The developers are sitting right over there, another software program that's very good. And it can then control the radio by Ethernet, and that gives you an extra feature that I'm going to show later, which is the data from the scope can get into the logging program too. That only works by TCP, not COM port. But you can't key CW over the TCP connection except by sending KY commands, which doesn't work real good. So I've got the next line down there, if it might be hard for you to read, it says COM4. Its little box for CW other is checked. You hit the set button, and very simply you set CW on the DTR pin and PTT on the RTS pin. If you're keying an amplifier, you can set a PTT delay so the radio is keyed before any RF comes out. And now that you've got that set, so you've got CW keying on your COM port of your logger, and you've got the control of the radio through Ethernet instead of COM port, now you can use this nice feature in N1MM. This is a new slide this year, pay attention. You can select window spectrum display. That's all you have to do, and it just comes up. You don't have to program anything else in N1MM that defaults to that, but there are some settings. And you will get on in your logging window, this scope screen, a copy of what you're seeing on your K4 pan adapter, and you will start, any spots that you're feeding into your logger will start to get marked on the display at the top. There is this little arrow button up in the top corner of the N1MM spectrum scope. And if you click that, a new set of dialogues pops up, and it's a little hard to read, but you can select that I want to monitor pan A or pan B, the subreceiver. And if you have 2 radios, do I want this scope to be on radio 1 or radio 2? And it also supports external SDRs, but with the K4, you simply select external waterfall, and it just works. And you didn't have to do anything but configure the COM port, the host name in that prior menu in TCP, and it just works. Okay, so tip number 11 is let's talk about macros. Don't be afraid of macros. You don't have to be a professional computer programmer to get your radio to do things with macros. It's just a string of commands that does what you would do by pressing buttons. And you can program more than one command into a string. So in this example, people don't realize it, but if you hold down the antenna button, it says remote antenna down there. They don't really have any remote antenna features. So for now, what you can use is use that as an extra button, because PF1 through 4 are already programmed with something at the factory. You may not want to change that. So if you hold down the remote antenna button, you can run a macro. This is if you don't have a K-pod. So how do you program a macro? Well, you tap the function key, and then you hold down this macros button, and then up comes a dialog here. And again, it's got this curly Q and this arrow, which means you can scroll through the list. And I scrolled down until I highlighted the remote antenna button. It starts out with the function keys F1 through F8, which are soft buttons on the screen, and they take 2 taps to execute, so they're not super convenient, but they can be used. So once you scroll down to the remote antenna section, it'll normally say unused before you do anything else. You then want to tap in this middle column here. There's 3 columns on the display. They really should have lines between them. But that column there is your label. A lot of people get messed up. They put a macro string in there and nothing works, because that's just documentation for you, or it'll display on the function keys. I always like to put in a label of what the command is doing. That way I don't have to look it up again. So if you tap in that middle area, you get a pop-up keyboard. By the way, if you have a USB keyboard connected to your K4, it's a lot easier to program macros than tapping one button at a time on the screen. But you can do it either way. Once you see this dialog up, you can start typing on your USB keyboard plugged into the K4, or you can tap the characters on the screen. So once you're done, you tap the enter key, and then the next thing you do is you tap that third column, and this is where you're going to put in your command. How do you know what command to use? They're all in the programmer's reference. Just search it for whatever you wanted to look for, and you will find the string for doing it. In this case, this magic command, #AR1, says do an automatic refresh of the reference level. Remember I had the auto reference level set? This automatically resets the screen. Sometimes you'll see the auto ref gets a little confused by a static crash or something, and the waterfall gets real white or everything, and it's not trimming the grass properly. You just hold down the remote antenna button once it's programmed with this command, and it does an auto refresh right there at that point in time. Even works when you have ref level set to manual, and it can give you a way to get an idea of what the band noise is, because it'll display the band noise level in dB, the reference level. All right, so what macros do I use on my K-Pod? This is the list. As I showed you, the remote antenna button is programmed to do an automatic reference level adjustment. I wanted one button that I could tap to automatically toggle diversity mode on and off. That / is a different kind of toggle. It does it completely on and completely off. Only works with a few commands like diversity. And you'll notice that I've got the tap and hold buttons on the K-Pod programmed for the same command in my case. So if I hold the button down a little too long, it still does what I want. And that's the case of that F1 key on there. K-Pod-1T means F1 tapping it, and 1H means holding it. And again, you can program up to 16 macros in a K-Pod that way. I guess I won't go through all these, but I've often asked you guys, if you have a problem, you see something, send me a screenshot. Please don't take out your camera and try to take a picture of the screen. It's too fuzzy. I can't see what's highlighted and what's not. And the files are going to be huge, 4 megabyte JPEGs or something. You don't need to do it that way. Just plug a USB stick into the K4 and then hold down your function key that's programmed down there. I have capture LCD, and it's the SS0 command. It's really handy for just capturing what's on the LCD screen without having to tap and hit function, screen cap, and things like that. And you can capture things that, like the menus or whatever, you're not sure of. So I really find it extremely useful to have a way of getting a screenshot very easily and post that to the list. I also like to toggle my subreceiver on and off, and you'll notice there on that K-Pod 4 tap, I've programmed my favorite audio peaking, APF audio peaking filter on and off toggles. And so it's easy in the lower left corner of the K-Pod for my left hand to hit that and turn on when I hear a weak one. Some of the other commands are having to do with swap. You may notice when you tap the A/B key on the K4, it's very slow. That's because it's swapping everything, the filters, the scope, the antenna, not the antenna, but almost everything else gets swapped when you tap that A/B button on the K4. It's very slow. If you just want to quickly swap the VFOs and leave the modes and everything else the same, the AB2 command does that. And that's why I've got it on a K-Pod, to quickly tap both, and then it just switches the VFOs instantly, and I don't have to wait. And remember, you were asking me about the turning the RIT on and off, and having the RIT up-down commands shift the display when I didn't want it to. Well, you can see that what I've done in F8, down there, 8 tap and hold, it turns the RIT on. That's what RT1 does, and then it clears it, and then I can move it up and down with my up and down commands in my software. And the one above it clears it and turns it off with RT0, so I can then shift the display with the RIT knob. Now, when I captured the screen, I left off the 3 tap. It's turning off diversity in the subreceiver. All right, we're almost toward the end here. Tip number 12, per band power. If you have an amplifier connected, it probably needs a different drive level on every band. The K4 is very good about remembering the last drive power you used on every band if you set this option to yes. I do recommend it if you're driving an amplifier. If you're not driving an amplifier, probably not. And not only that, if you connect an Elecraft KPA 500 or 1500, you'll get 2 levels per band. How are we doing on time, Scott? I'm off? All right, I'm going to go real fast. Don't forget this presentation will have some other things. There's a TX delay menu for so you don't hot switch your amplifier or hear a big pop when you come back. And finally for SSB, and I posted this many times, you want to use your graphic equalizer about like this to get maximum punch out of your audio. and then you can then program your voice memory. So here's a summary of the tips today. And as a quick bonus feature, I'm going to show you the screen that you haven't seen before if you haven't tried the K4 beta. But you can simply now add a remote by hitting this new globe icon down here. You tap New, you fill in the host IP address, give it a name, use UCP, save it, and then tap Connect. And when you hit Connect, boom, you're connected to the remote K4, and it feels just like you're operating your own paddles and all. And you see this menu down here indicates that you're now connected to somebody else's K4. And now we can talk more about remote. So
Before we
with
go
the
there,
server,
Bob,
you just
before you
have
go
to
there.
put in a password and max clients on the server side, and then people can connect to you.
Yeah, before you go there, Bob, is Rob Sherwood here? Come on up,
C0B
Rob.
is here.
Well, yeah. Could you set his slides up there,
Okay.
Bob?
This is slides on here?
Yeah, they're on there.
Thanks.
And then as soon as Rob Sherwood is done, I will have.
Station is set up using band data into a band data decoder that then drives bandpass filters for SO2R operation. And I've got Elecraft amplifiers which have wonderful remote control capability, KPA 1500 remote, KPA 500 remote, KAT 500 remote. They're all client server, so I have a little Intel nuke up in the mountains that runs the server side of these wonderful applications. And I use PST Rotator AZ to turn my Green Heron rotor controller. And it also happens to have a step IR controller as a side effect, separate window. So all of that put together makes for a remote control experience that's essentially the same as being there. First, let's talk about turning on the K3. One of the really neat things about remote rig controllers with K3 was that you push the power button on the local K3 and the remote K3 turned on. The K4 doesn't have that capability built in. So what I do is I turn on the power supply using a remote power switch. These things are, you can get them for as little as $8 on Amazon. I happen to use a digital loggers box that has 8 separately controllable outlets and a wonderful web interface. And the K4 has a pin in the accessory socket, a pin that's used on the K3 by the remote rig controller, but you don't have that with K4 to K4. So Bob provides a little box called a K-ON, K-ON, which plugs into the accessory socket or an expansion of the accessory socket. It says, and one of those pins says, there's power on the K4. And another one of those pins says, pulse me and I'll turn on the K4. So you plug the K-ON into the accessory socket, you turn on your remote power, your power supply with a remote power switch, and bingo, the K4 comes on. You can turn the K4 off later. If you want to live dangerously, Eric will tell you that it's not dangerous. You can just turn off the power with your remote power switch. I always use a PS0 command to turn off the K4 before I turn off the power supply. To each his own.
Maybe Ed could talk about contesting for a minute.
Contesting has been great. The first contests that I did were CWTs because they're every week. They're CW only. I did an NAQP RIDI with K4 remote. I used AFSK. I understand some folks have been using FSK with K4 remote. I haven't tried that yet. I haven't done a lot of phone contesting, but I've made a lot of phone contacts with the K4. It's just fine. The really neat thing about contesting with K4 remote is that you set up your logger locally, if you're doing K4 to K4, set up your logger locally with the K4, and eventually you'll be able to do that with a K4-0 or a VK4. If it works locally, you connect, and suddenly it's working remotely. There are no changes, no cabling changes, no command changes, no switch changes, no buttons to push. All of a sudden, once you're connected, your logging program is controlling the remote computer. I use N1MM. I think Bob uses WinTest. I've also used Rumlog on my Mac. And, well, the logger can't tell whether you're local or remote. Be careful. You probably have separate logs for the stations in different locations. So make sure to change logs. That's up to you.
Hi guys, I'm Dave, K4 Sugar Victor. My particular application, I don't know if you can hear me here. My particular application is using a remote on my property. I've got a ranch in Wyoming. It's connected via Starlink. I live in North Carolina also, and it's also connected on Starlink. That provides, given issues, unlike a DSL connection or a fiber connection. And I'm here to report that the K4 works very well on Starlink. Starlink comes and goes in performance, unlike maybe your home connection, but I've had very good luck with the K4 on that. Currently on my Wyoming location, I have a K3 and a rig remote, which I've been using for quite some time, and it works very well, but it comes with the normal problems you would normally have in a remote rig. There is audio connection issues and different things, but I'm primarily a CW guy and a DXer, and I use my Wyoming site both from a local place when I go there and also a remote from wherever I am. My daughter just had a baby, and my wife spends a lot of time in Nashville, so I don't know where I'm going to be. I can be actually anywhere, but the benefit is I just finished putting in another remote site in North Carolina. So no matter where I am, I can run it. Now, here's the benefit. I've just purchased a couple K4s, so I'm going to install a K4 in Wyoming, and I'm going to have a K4 in North Carolina. So I can be in North Carolina and operate local, and I can also work from Wyoming. I can be in Wyoming. I can work in North Carolina transparently. I can be in Nashville, and when we finally get the VK4 software or a K40, I have full connectivity using my remote from all of my homes spread all over the place.
How did you get around the Starlink CG NAT issue?
Oh, good question. So the question was, how did I get around the CG NAT issue? We have a VPN connection out of fiber connection out of Missouri. And we use that as VPN boxes using MikroTik routers from there. And so essentially we just have an extension network, all essentially the same, but just a different subnet. And that works very well.
Write up an application note?
Yes, we will. When I finally get it all finished, I'll do that so everybody can see how that works. But I've got an IT guy, Jay, W0JD, is worked all this through, and it really works well. So both the K3 with the remote rig works well, and now the K4 is even going to be better. One of the problems with a K3 remote rig is we're so used to looking at the spectrum analyzer. You want to work split. Well, I got two sources, so I can work split. But the problem is you can't see who he's working, right? And you're chasing the DX. Well, now with the K4, it's absolutely transparent. So it's a really great application for the K4. So for me, it's only going to get better. I'll write up the application and how I hooked all this stuff up. So in case you get in the same situation, you'll have that information. So thanks a lot. Short guys. Yeah. Height challenge. Yeah, well, there you go. How's that? Okay.
Hi, I'm Ed, W0YK. And just quickly, I'll add one of the applications that we haven't really talked about, which happens to be the ARRL sideband contest in March. And it's kind of odd that I'm talking about that because that's the mode that I least use in contesting. And this is a remote down into our station in Aruba that I'm typically operating CW or sideband down there. We're in the process of remoting that station for obvious reasons, and so for the last year, most of our operations have been hybrid. That is, we've had people on site, and then it's usually been me being remote back in California. So in this contest, we were doing a multi-2 in the ARRL sideband contest. We had a K4 down there, and it turned out, we didn't plan it this way, but it turned out throughout the weekend, Doug Grant, K1DG, was there locally, and he was on mostly on 40 meters and 15 meters during the day. And again, it wasn't a plan, but it just worked out that way. And I was back in California, and we tag teamed through that. He did most of the operating, but it was really slick because he could just instantly get up. I could just keep running the pile up, and he'd come back and run it again. So it was as though we were sitting side by side. And our experience through that was we had a few minor issues with latency and so forth going through the internet down to Aruba. There was nothing special that we had to set up, and it really worked very smooth. I was amazed. There was one time, 3 o'clock in the morning, something happened and the K4 was doing something weird, and I had to get on the cell phone and call John to reboot the K4 down there. Never did know what that was, but you know, we're working with a computer and these things happen, and so those are just examples of things you have to consider in a remote consideration situation. It's not going to be 100% foolproof, and so you have to think about all the corner cases. But I've been just amazed at how well it's worked. Before that, we were using the remote rigs with the K3s, and that was really painful. And I don't think I'll ever do that again in my life. Now I'll just refuse to operate unless we can use the K4. It's just now that you have that solution, you just never go back.
Anybody with questions for our panel? Raise your hand. I'll bring the microphone. Get you second, third there, okay?
I'm going to try to answer all your questions ever today.
Hi, most of you guys talked about your controlling your own radios, essentially. The scenario where we were testing out, you know, everybody's different radios. A lot of different people have different configurations of things like Vox and how they do CW. I ran into the side tone acting funny in some guy's setup. Is there something coming out, or maybe that's an application note about?
Well, there's a lot of parameters that you want to change on the client only, and like volume, and you don't want it to affect the server, but maybe side tone pitch has to be done at the server. Even though it's generated locally, when you're keying by paddle, that pitch would be your own. But if you hit a memory button and then that side tone comes from the server, you'd hear a different side tone. So they're working that stuff out about how much should be on the client side, how much on the server side. The goal is that stuff that has to be done on the server is there, and everything else would be saved on the client. But it is useful if you host a server shared by lots of people to take a backup with all your settings the way that you like them. And that way, after they're all done, you can just restore all those and your radio's back the way it was before they messed with it. Are there any more questions?
Okay, very good. We got two right here and then one here. And then I'll come over to that side.
Real quick, you say you used a PST rotator. Do you run that locally on your computer, or do you VNC into the remote site?
It's a client server pair.
So you set that up remote?
I run the server up in the mountains. I run the client down in the valley.
And that works well?
Works great.
Stepper and rotor?
Yeah. It's 2 port numbers. You have to do some port forwarding at the server side.
You do need 2 PCs to have a PC running at the shack all the time to make that work. There are boxes like Moxa boxes that will actually let you, through the internet, talk to a serial port. So there is a way of, without having a box running at the remote site, to actually do things on serial ports.
All of the remote control apps that I mentioned can run locally at the control site with virtual serial ports at the other end. I have tried that. I've gotten it working a few times, but I don't like it. The client-server pairs, for me, are the way to go.
I've got a question about CG NAT. I'm over here. Using a cell phone or a smartphone, the bandwidth required is probably going to fit within a good cell phone connection. But is CG NAT going to be an issue that I've got to have to deal with a cell phone, using that as connectivity for the K40?
So you would need some type of Ethernet to Wi-Fi connection, and then your cell phone connect as a Wi-Fi hotspot that your K4 connects through your cell phone. But to get clients to connect, you're probably going to need to run a VPN app of some type on your cell phone and have it connect to your VPN setup. I'm no expert on setting up VPNs. There's a lot of different flavors out there, but there is a way to put your cell phone on a VPN when it's connected to the cell phone network, And that kind of makes it a part of your private land that everybody can get to. So that should be possible to do. I can't tell you how to do it here. Yeah.
Dave, I kind of rejoiced when I heard you say that you were using Starlink. I've got a cabin in Utah, and we've got Starlink there because nothing else works. But then I heard you start talking about CGNAT, and I'm not going to ask you to explain that right now. I'll Google it or something. But I kind of despaired. So it's like, is this some huge issue that I know that Starlink doesn't do port forwarding? Is that part of the problem?
Yeah, Starlink doesn't do anything for you except just transfer data. So by putting a VPN in for us, we can do port steering, which you can't do on Starlink. So it's just transparent. It's a medium just to send data from point A to point B. So we put in this VPN that allows us to do whatever, and it's essentially an extension from our network from one to the other. So it works very well.
I'm a little familiar with VPN, not a lot. Are there some resources? Can I send you an email?
Yeah, send me an email,
Okay.
and I'm going to write this whole thing up
Okay.
once it all gets up, and it worked out very well. Of course, Starlink doesn't do port forwarding like you would with your normal internet service. So you have to put a VPN in, which you can do whatever you want then, and the Starlink just sends data from point A to point B for you.
Okay.
Okay.
Thank you.
Well, thanks. Let's give him a round of applause.
I have one last announcement. Thank you, guys. One last announcement. I mentioned the K-On device to power up your K4. I did bring about a dozen of them with me. And if you already have an old Y box, it plugs right in. Or if you're not using the accessory port, it plugs right in. If you need both, then I can put that in a Y box V4 for you. But I didn't bring any of those. So anyway, if you want one of those, see me, and I'll be happy to get you one. Thank you.
And until we get kicked out of here, I'll be trying to run VK4 in the back of the room.
set.
Is this live? All right. Are you guys ready to do some SOTA? Okay, so thank you all for coming to the 2024 SOTA Forum at Hamvention. It's so exciting. We've been doing this for a number of years now, and it seems like every year it's growing a little bit. This year we got an even bigger room, and the growth in the forum pretty much mirrors the growth in the program, I think. The SOTA Summits on the Air program has been just really growing in the time that I've been doing it, which is definitely not as long as some of you have been doing it. It's a wonderful, great program. In part of the Hamvention theme of engaging with the community, we can narrow that down, and we're going to talk today about engaging with the SOTA community. So last year, the three of us, Charlie, NJ7V, Brian, W7JAT, and myself, Keith, KR7RK, did a forum, and we're going to do another one this year. I have to say, Charlie and Brian are two of the best SOTA ops that I know, and I'm sure you all don't need a lot of introduction to these guys. So without further ado, I'm going to turn it over to Charlie, and he's going to get us going. We're going to kind of do a 1, 2, 3 approach, and we do want to encourage audience participation. So please raise your hand or respond to questions, or let's all have some fun as a community here. So Charlie, have it.
All right. Let's see. Let's get it like that. All right. Thank you, guys. So we are all, it's fine-tuning your SOTA experience, right? That's what we're talking about today. And like Keith said, we've got 3 different topics that we're going to talk about to help you fine-tune your SOTA experience. So mine is coming up here in just a minute. Just a little bit about me. I have a YouTube channel. I think a lot of you know that, Red Summit RF. And but I also, more important than that, love to do SOTA, the Summits on the Air, in the Whiskey 7 Alpha region or section. And I'm very active in Arizona, but I also love to get out of Arizona and activate in other areas. And I also really enjoy people who reach out to me who are from out of town and visiting Arizona. And I love getting out there and doing joint activations with people and getting to know new people. I just went on a joint activation with a guy named Derek from Reno, Nevada, a good guy, and it was a really fun activation. We did Mount Doom, and we actually did 3 summits. The first summit was called Pentagram, and that one had a pentagram on top. It was really strange. And then we did one that really didn't matter much. And as we were sitting on that second summit, I was looking over at Mount Doom, and I said, Mount Doom, that doesn't look, the name doesn't really fit it. It's just like this little flat thing. Well, as it turned out, it lived up to its name. It took us a long time to get up there. It was very steep, but it was a fun experience. I have been a ham radio operator for since 2005. I got involved by participating in Field Day, and about 6 years it took me to get my general license. I was pretty satisfied with doing VHF, UHF, repeater stuff. And then I met Brian, and he took me out on a summit, Mount Pelee in Arizona, and we did my first QRP operation for HF. It was my first time on HF, and my first time QRP, and my first time SOTA, and it was a great experience, got me hooked. And so I started SOTA with VHF and sideband, but I learned very quickly that it's better to do CW on SOTA activations because of two reasons. One, it's just, as you know, the signals get out there better, but two, everybody's on CW, so it's not quite the same now. I mean, there's a lot more sideband operators. We know that, like my friend here, Robert, N3BZ, he has got his GOAT, and he did that all sideband. In fact, he's a third GOAT now, all sideband. So, you know, it's possible. All right, so let's just talk a little about engaging the SOTA community. And I feel very stuffy right here. I'm going to walk around a little bit. All right, so engaging the SOTA community. We all picked a topic that we thought would be good to help you fine-tune your experience for Summits on the Air. And the topic I chose was engaging the SOTA community because I found a bunch of information and a bunch of help through the SOTA community. And I realized early on and throughout my SOTA experience that if you engage the SOTA community, you have a better chance of enjoying yourself and in learning things that you may not know. There's always new things coming out, innovative things, and if you engage the SOTA community, you're on top of that. So let's talk about that a little bit. So what is the SOTA community? You look right here, we have W70 Jefferson State Annual SOTA Campout. So it's a social group, a group of individuals with common interests. That's what to me, the SOTA community is. And when I think of the SOTA community, I'm not just thinking of in person. There's two aspects to it, but a SOTA community is a community of people who have a common interest. And let me move this slide here. So why engage? Share new ideas, get assistance, make friends, and stay informed. And these are all things that I think of when I think of engaging the SOTA community. Here's a guy named Sly. He's activating VE6ML on Mount St. Bruno. And he looks pretty comfortable there. I chose this picture because I think it's very fitting for how some of the operators are out there. I mean, we really enjoy it, and we can really be casual, but we could really take it seriously. It's just entirely up to you. So places to engage. This is kind of the meat of what I want to talk about. When you think about engaging the SOTA community, one way to do that is in person. So regional SOTA groups. And when I talk regional SOTA groups, what I'm talking about are those groups that meet eyeball to eyeball, that have some sort of an activity where they interact with each other physically, or at least they're in the same room together. There's also virtual SOTA groups, and there are a lot of opportunity to engage with very smart and experienced people in virtual SOTA groups. And I'll talk a little bit about what some of those are and what some of the things you can find in those virtual groups. And then lastly, individuals. I started out my little talk here on my SOTA joint activation with Derek. It's a great example of just doing an individual one-on-one, you and another person getting out on a summit. That's very helpful. And as a experienced SOTA person, I welcome anybody who wants to learn from me. And I think that there are many people out there who feel the same way. And as a person who was new, I really appreciated having somebody take me out and show me what gear was being used and how to operate. And so there's two sides to that coin. So if you're in our SOTA community, if you're a SOTA operator or activator, or a SOTA activator or a chaser, consider both sides of that coin. So I know this print is kind of small, but I want to recognize these groups so that you can, if they're in your area, you know about them. So these are the regional social groups, eyeball to eyeball, in-person groups that I know about. It doesn't mean that there could be more here, but these are the ones that I know about. So there's the W70 Jefferson State group. That is kind of pretty much the Oregon area, upper left of the United States. Amy, Alpha Golf 7 Golf Papa, coordinates that group, and she is also part of a larger group, which is the Pacific Northwest group. And that's a larger group that encompasses Oregon, Washington, a little bit of Idaho, and maybe a little bit of California too. It's Pacific Northwest. That's K7ATN. His name is ATN, right? Or Bill. ATN is in charge, but we have a guy named Bill, K7WXW, who is the person who coordinates some of the activities. We have NorCal, Rex, KE7MT, great guy. SoCal is Mike, KN6EZE. Arizona is Pete and myself. Pete is WA7JTM. Colorado, Bob. A lot of you might know Bob, K0NR. Bob is here. Great. Thank you for raising your hand. Montana Dakotas. It's a new group. You may not know about this group. Alan, KH7AL, is starting to organize a group in that area. So they're new, but they're there. Southern Central Canada. So Jesse, VE6JTW, he has a YouTube channel. And then his friend Malin, VE6VID, who also has been on many joint activations with me, one just recently. They're kind of the guys that are coordinating Canada. And so when I reached out to them, I said, what area would you guys consider yourself in? And they said, all of Canada. And I'm like, okay, it's good to be inclusive, but all of Canada is a little big. So I took the liberty of naming them South Central Canada, because really they're in the Calgary area, and mostly there are some people who kind of come in from outside, but that's pretty much where they are, because we're talking physical, in-person stuff here. Carolinas and Georgia, that's Pat, Whiskey 4 Delta. Many of you know him. I can't remember what his call sign used to be, but it was not easy to remember. But okay, cool. And then Northwest, this is Whiskey 1, Whiskey 2, and Whiskey 3. There's kind of two groups there. We've got Alpha Juliet 2 India. It's AJ. He kind of coordinates a northwestern group, but then there's also Alpha Zero Zulu Z. What is it? What is it? Yeah, Whiskey 1 Zulu is coordinated by Bob, and Bob's call sign is AC1Z. Yes, AC1Z. Sorry. And for some reason I left him off here, but he's also does his own group. Last is the Midwest group. And we have Paula over here. She can raise her hand. She's coordinating that group. That's the Whiskey 9 group. Raise your hand again. Some of you. There you go. All right. So if you are in one of these areas, then you can reach out to the people that are on this list. I'll make this slide available so you can look them up. And you can contact them. And they'll have a place for you they have meetups. So there's a few things that we do in person. One, most importantly, is we do campouts. And typically we do campouts near summits. And so we'll spend the night and we'll go do some summits together, and then we'll camp. And so this is a really good opportunity to interact. You get up on a summit, you do a summit, you talk a little bit, you get back to camp, and you share all your gear. I was in they had a camp out in the SoCal camp out with Mike, KNEZE, in Big Bear. That was probably 2 years ago. And I learned so much from sitting on the picnic table, looking at everybody's gear. Everybody brought out their gear, all the different antennas. At that time, I was still using an 18-gauge 17, 20, 30, 40, 60 meter dipole. And so it was sitting on the table, this big hunk of wire, and they're like, what is that? Because their antennas were like, little, and mine was big. But that's what I had at the time and what I was using, but they kind of mocked me, and so I decided to downsize a little bit. But I learned a lot of other things, not just that. It was a great experience. Okay, so next, these regional groups. The campouts, there's also meetups. I host a meetup in Arizona quarterly, and we call it GOATS. It's the gathering on the east side, GOTES, but anyway, it's a fun group. We usually have 10, 12 people that meet at a restaurant, and we just shoot the breeze. We also have an annual gathering where we do awards, and we do recognition once a year, and so that's a lot of fun. There's also special on-air events, and let me pause right here, and I wanted to announce one. It'll come up again, but there's an event coming up encouraging YLs to participate in a summit on the air event. And I think this is a summit-to-summit event, right, Paula? Okay. Okay, Paula. Do I need to repeat that for any of you? We good? Okay. Okay. Okay, we'll come back with you and give you the microphone and have you tell us that again in a minute. Thank you. All right, so also there's a special event. It's really not in person so much as it is you kind of coordinate stuff together. And I have here 10-Point Madness up. Our section, or not section, our association hosts 10-Point Madness every year. Everybody gets on a 10-point summit simultaneously at the same time. Started out just Arizona stations, and we work summit to summit. And so you can imagine you can get 300-400 points, summit to summit points, if you get enough people. And we have had as many as 37 people on the summit at the same time in, I think, 6 or 7 states participating. It's become very popular. And so I know that there are other events in the Pacific Northwest. We've got the Whiskey Zero Charlie, the Colorado 13er event, or 14er event. There's many summit-to-summit events as well. That's the one I have up here, Colorado 14er. All right, so also, there's, like I said, the campouts, but we have an event coming up I wanted to mention from Whiskey 7 Alpha. 6-meter summit-to-summit event. 6-meter summit-to-summit event. That's on June 15th. Get on a summit, and we're going to hope that the band conditions are good. We're going to hope that the 6-meter has an opening. And if it does, we're going to be amazed. But if it doesn't, then we'll just work ground wave, and we'll work everybody on other bands and get our summit-to-summit points. But we're going to try. We're going to take a 6-meter antenna and radio on the top of a summit on June 15th and try to get some 6-meter summit-to-summit. It's pretty rare. You don't have that a lot. So we want to try and see if we can make that happen. VHF contest the week before. Week before. This is June 15th. VHF contest is the 8th and 9th, I think. All right. Now let me talk a little bit about virtual groups.
Some things are not allowed on the plane at all. Hiking poles. Everybody here, I'm sure everybody uses trekking poles, or for the most part they do, right? Those will get taken away from you if you decide to take them in carry-on luggage. So that's something you need to make sure you check, and we'll talk about that a little bit later. But batteries, I see that all the time. Can I travel with my batteries? Yes, you can. They can't be spillable, and they've got to be under a certain size. The actual size is listed on the TSA website, and we'll get into that a little bit later. Let's see. So because of what I did for a living, I was not allowed to check my bag, because a lot of times I would be walking through the terminal with my bag, my phone would ring, and they'd say, don't get on that flight, get on this flight. And my bag's checked. Now it's other side of the country, and it's going to be days before they can get the bag back to me, and I can't work. So I was prohibited from checking my bag, which was a good thing, because I didn't like checking my bags anyway. Overhead bin's a lot easier, it doesn't get lost. But also all of the items in my bag, especially the battery, I couldn't check it, I had to take it out. So certain items are always kept separately so I can remove them from my bag and find them easily. So batteries. Bioenno 4-amp hour battery is what I normally carry. Never had a problem with anything that size. As you get bigger, they go by wattage, which most of the people that you're going to be talking to in airport security are not going to be able to tell the difference between a 150-watt battery and a 4-amp hour battery. So just watch the size, keep it within that limit. And again, that stuff is spelled out on the TSA website, and that's where I would go for the most current information. So everything you pack, make sure you pack it so it's not going to get broken. Wrap it, put it in a case, something that's going to protect it from getting bounced around should you have to check the bag, because I'm sure you've looked out the window and watched the people throwing the bags on the belt into the plane, and you've said, yeah, When I was working as a mechanic at Sky Harbor, I once watched a guy, one of our baggage handlers, was trying to move a tug, and it wouldn't go, and it wouldn't go, and it wouldn't go. Get off the tug, go see what's underneath it. Nah, that's too hard. I'm just going to gun it. Well, this bag flew out the bottom of the tug like a zit that just got popped and went all over the ramp. So just think about those types of things when you pack your stuff. If it's something that you, like a nice KX2, KX3, or any radio for that matter that you worked really hard to get, make sure you can get that out of your bag. I wouldn't recommend, would not recommend checking those bags, those items if you can carry them on. So in the United States, I've never really run into a problem with having to have my license with me other than when I've gone to places like the ARRL headquarters. If you happen to be up in Connecticut and you got an opportunity to go operate, they usually want to see your license before they let you operate their equipment. Over in the UK, when Eve and I were in the UK, we actually went to Bletchley Park, which is the home of the RSGB's version of W1AW. And we were allowed to operate because we had our licenses with us, but if we had not had our licenses, they would not have let us operate. It was kind of cool. We got to operate, I don't remember what the call sign is, but it's their station at Bletchley Park. If you ever get an opportunity to go to the UK, make the trip to Bletchley Park. It's well worth it. The other thing you can bring with you is a list of the items, a printed list of what's on the TSA list, so that way if you do get stopped for extra screening and they start going through your bag and they hold things up and they tell you, well, you can't take this, you have the documentation, you have their list in front of them. If it gets down to a point where the guy that you're dealing with, it's just the guy that's pushing the stuff through the belt, really does not want you to take it and you know you're right, don't back down. Be polite, be professional, don't make yourself a news story, but ask him to get his supervisor over, bring the supervisor over, have a conversation with the supervisor. Ultimately, if you've got the documentation, you're gonna be fine. I've only run into that once where I've gotten to the supervisor level and he's come over, he looked at the guy, they stepped off to the side, a little bit of conversation, my stuff got handed back and I went on my way to work that day. Internationally, you could also have problems too. The only time I've really ever been flagged and stopped for extra screening other than once in the US was in Scotland. And it was kind of a funny story. We got through, I was traveling with an 817. We were getting on a flight to go back to London and got flagged for extra screening. The agent that was screening it pushed us off to the agent that was going to do the secondary screening. He looked at me and asked me if it was a particular person that flagged us. He handed me my stuff back and said, "Put your stuff back in the bag." And as he walked away, he said an expletive and kept on walking. So he was not too pleased with the person that flagged us for extra screening, apparently. Okay, so I put this little line in there because it's kind of a joke from when I was flying when I was still doing a lot more stuff going through security, especially as a professional pilot, which was understanding why your HF radio might be a threat to national security. A lot of little things in the bag. Thankfully, there's been a few times that the TSA has helped me lighten my bag because I had a 3.5 ounce, I didn't have a 3.5 ounce item in the bag and they shaved that extra weight off for me, so it made the bag lighter. I had to give that stuff up, and that's one of those items that might be a threat to national security. So the main thing the main point I want to get at here is know what you can bring, know what your rights are as a passenger, as a citizen, follow their rules and stay within those rules, but understand that you have the right to take this stuff on the plane as long as it falls within the rules, the confines of what they say you can and cannot take. So these are items that are absolutely prohibited, and I brought them up mainly because they're stuff that we would potentially use as activators. You might think about throwing it in your bag, especially if you're going up to Yellowstone or up into bear country. Bear spray cannot go on the plane at all. Checked luggage or carry-on, don't bring it. A lot of places will rent it for you, or you can just buy it and give it to somebody when you're leaving to go home. Bear bangers, for those that don't know what they are, it's basically a pyrotechnic device to make the bears run away. Don't bring that. Spillable batteries. So sealed lead acid batteries are okay. But if it's a serviceable battery, it's something that can open up and leak, cannot bring that on the plane. Liquid fuel of any kind, that's should go without saying. But liquid fuel, the small butane containers for stoves, I'm not 100% sure that those are not okay, but I'm pretty sure they're only okay in carry-on if they are at all. Check TSA.gov for the up-to-date list before you go on a flight because it changes all the time. They are their own agency. They don't have to have congressional legislation to change the rules. They change it as they need to. So this is stuff, again, this is when I was talking about carry-on stuff. You can bring your trekking poles, but they got to get checked. You can't pack them. Keith and I were talking about this, and he was on a flight where a woman had to basically surrender $150 trekking poles up in, was it New Hampshire, I think you said? It doesn't really matter, but up in New Hampshire. I had to go through Mammoth, California quite a bit, and they have a big picture of trekking poles and a set of them bolted to the wall by this checkpoint saying you cannot take these with you. They will be confiscated if you bring through security, because apparently it happens quite a bit there, big hiking area. Tools over a given size, check the TSA website for what that size is. I'm not going to put it in there because it may change. I don't want it to get taken the wrong down the road. Knives, again, there is a certain size on a blade that you're allowed to carry, but double check and make sure what you have is good. Hatchets, tent pegs. We all have pegs for holding up our pole. Those cannot go in your carry-on luggage. They can only go in checked bags. And check the TSA.gov website for details. So for international travel, I've heard a lot of different things on this. When we traveled internationally, we went to France, UK, Scotland, and I've been to Mexico and Canada with my equipment. Never had a problem getting it into or getting it out of the country. Some places, they might want to see a copy of your license. Make sure you have your license with you. You can reach out to the local or to that country's national organization, their version of the ARRL, and ask them if they're aware of any problems. Sometimes there's specific airports where you'll hear that this airport, they're a little more conscious about what you bring in, and they might get some more questions. Just be prepared for that. Kind of know the lay of the land. Brad? Excuse me.
So from personal experience, I know because I travel a lot, if you have expensive gear, have the receipt. Have the receipt, because if you don't and you're leaving the country, it's very likely they're going to want to tax you. So if you have the receipt, a picture of it on your phone or whatever, really makes a big difference.
Thanks, Brad. Yeah, so have your licenses with you. Just check their regulations. Some countries have bans on specific radios. I've heard some stuff about I believe it was Laos or Cambodia. It was Cambodia, where they have pretty much banned all of the HF equipment, and then there was a push in Cambodia by the people that live there to say, hey, we want to have these 3 radios be authorized for us to use, and one of them was like the FT891 because it was fairly inexpensive. But they recently banned all their equipment. Can't use any HF equipment there at all. So know where you're going and look at the rules, because you can find yourself on the wrong side of things, and they don't really care. So you have a $1,000, $1,500 KX3 in your bag. That's it. It's somebody else's now. So airline staff, for the most part, great people, want to help you about service, especially once you get into the cabin. But you've heard this probably 100 times when they're checking bags at the gate. We're looking for volunteers to check bags. You're like, oh crap, I'm in, I'm in the D group on Southwest, which means not taking anything with you into the cabin. Nothing's going in the overhead bin. The C group is even worse because that means center. You're going to sit in the center seat on the plane probably. But they always tell you, hey, make sure you take out any batteries from your bag. And that's where I got into before, having stuff ready to pull out and easy to find. Make sure you get that out. If they're going to take your bag from you, or you just realized, hey, I just got on the plane and I got a battery, I've got my radio, ask them to give you the bag back real fast to get the stuff out. They're more than happy to help you, but you got to talk to them. Same thing with the gate agent. Just make sure you take out what you need. If they want to check the bag, sometimes they have limits. You can carry, one carry-on, one small item. They have to check your bag, explain to them, I've got 2 small items in it that I need to remove from the bag. They'll usually let that slide. Here's a little inside trick. How many people know you can bring a frozen bottle of water through security? There you go. So if you ever want to bring a sandwich with you on a plane in a small cooler, you can bring any size bottle of water with you as long as it is frozen solid. Cannot have any liquid in it. It's got to be frozen solid, and they will let that through security. So if you want to keep your sandwiches cold, you're good to go. It's not a threat to national security until it becomes wet again. then it's a threat to national security. And before that, it's actually okay. So main thing is we all want to travel. There's a lot of great places to go. There's a lot of great places to do SOTA. Don't be afraid to do it. Take the gear with you. Just know what you're bringing with you, know where you're going, and follow the rules. If you stay in the lines, you're going to be able to go. It goes both ways. Know what you can do, know what you can't do, and be prepared to defend it if you get flagged. Most of the time, it's a non-event. So I got hit 2 times for extra checks in almost 10 years of flying. It's really not that big a deal. So anybody, questions? Anybody want to tell a story about a good experience or a bad experience and how they got through it? I'd love to hear it. One in the back over there. Mike's on the way.
You mentioned when dealing with TSA, stand firm, and it helps to have documentation.
Yeah.
Where do I get documentation that says my KX2 is not a threat to national security?
Well, you can go on their website. You can look at their list of electronics, and the item itself is not on the list. You're allowed to bring a radio on, and it's a radio. So yeah, it'd be fine. And that's on the TSA website. So look for the electronics in that list. You can show them right on the list, hey, this is a radio, totally okay. Your list says here I can bring it with me. And I tell you, I've never had a problem taking my gear with me on the plane in that way. Anybody else? Robert. Mike's coming in, Robert.
I was just going to comment that when you take your gear with you out of the country, out of the state, take a manual with you. Take the brochure so they can look at it. It says it's a radio. They can compare the two, and they say, well, that's a radio. That's good to go, or not good to go. If you do decide to go to a different country, check to see what you need to do as far as licensing to be able to legally operate in that country. Some of the procedures you need to do to get a license remotely in different countries, it could take 30, 60 days, and usually you have to work with a proxy or somebody that's a ham operator in that country to be able to process a temporary license for you.
Okay, well, I'm going to turn it over to Keith, only because we're running a little bit of time. We'll grab some more questions in the end. Keith, take it away.
All right, thanks, Brian. So question, how many mountain goats are in the room? If you're a mountain goat, raise your hand. Awesome. How many of you are on the way, even if you only have 1 point, you're starting your journey towards mountain goat? Raise your hand. All right. How many of you are chasers? Raise your left hand. I'm just testing to see if you're listening. Okay, so I want to apologize in advance. I'm a little tired because yesterday I was bushwhacking my way around W8O summits, and I think I might have got poison ivy. I definitely got ticks, so I hardly slept last night. But I want to have some fun with you guys. So what I'm going to talk about is kind of personal. I'm just going to make myself vulnerable for a minute. If you know me as an activator, you know that there was a period here for the beginning of the year where I didn't activate a whole lot, which was unusual for me because for about 7 years I had been activating quite a lot, and but life kind of took some turns and I had to make some decisions, and unfortunately I slowed down a little bit on SOTA. And so I thought, in kind of evaluating what happened in my own situation, maybe I can share some ideas about what happens when life gets in the way. But actually then I thought, that sounds kind of negative. So what I really want to talk about is enjoying SOTA when you're a busy person. So how many people in here consider themselves to be a busy person? Probably everybody, right? If you don't think you're busy, come share your secrets with me later. But ham radio in general, it attracts intelligent people, it attracts active people who want to keep their mind occupied with stuff. And so you're just inherently going to be a busy person. And adding SOTA to your mix really increases that quite a lot. So I'm going to try to share a few tips. And if you guys have any ideas as I'm going through this, please raise your hand, interrupt me. We got the mic going around. Love to hear from y'all. So, you know, just a few of the things that challenge us as SOTA operators. Efficient use of your time is really probably number one. But you've also got a challenge. FOMO stands for fear of missing out. And SOTA, you know, SOTA, it was not designed to be a competitive program. And they occasionally, the management team somebody will step forward and say, you know, this isn't supposed to be a competition. But at the same time, we got all these points and we got challenges. And then sometimes it's fear of missing out. Like I personally am afraid that I'm missing this year's 6-meter activity because we scheduled a trip to visit my wife's parents that exact weekend. So I know I'm going to be in Toronto, Canada. The chances of me catching Charlie on 6 meters, probably about 0. And that creates a fear of missing out because I'm like, all my buddies in Arizona are going to be on all these summits, making all these awesome contacts. And that can make you feel kind of bad. And so how do you deal with that? And then there's family and friends. And you can get carried away with SOTA, let's be honest. You can get carried away with anything in life. And sometimes that it can be detrimental to your relationships with your family and your friends. And so you have to juggle this big mix if you want to be a SOTA operator. Does anybody filter and you can say, I want to filter by the number of activations? By default, it's going to show you all the summits, but if you filter it and let's say 5 activations or more, and if you look at those green dots, there's quite a lot less. In fact, I'm going to switch back to the previous slide, back and forth. Can you see the difference? Is that showing up okay? Okay. So that would be one way to do it. Now, what if I say, well, 5 doesn't mean a whole lot. Let's make it 20. Now look at the difference. Whoops. See that? We just erased a whole bunch of summits. So if you were to go into Spotless and filter it and say, I only want to see 20 or more, you're going to find there's only 6 summits there in that range. One of them is that one in Cincinnati that's across the street from a Taco Bell in a church parking lot. Super easy to activate, so of course that's the most activated summit, or one of the most. Another one is Campbell Hill up north, which is the high point, I believe, of Ohio. I think there's 2 places that claim that, but anyway, so now you've got it narrowed down. You can say, okay, these are probably either drive-ups or very short hikes. Another tool that I personally love, and I think it's SOTLess kind of pushed it to the side, but it still exists. And in fact, SOTLess actually feeds a lot of the data from this, is the SOTA mapping site. If you go to the SOTA mapping site and choose the range, and the URL is just sotamaps.org/range. And it's going to pop up, and you're going to go, wait a minute, I'm not in Africa, so I don't really care about what summits are in Algeria or whatever. Well, what you do, okay, now the first step is I've circled, there's a button there that says define range, and then you fill in the information you want. In this case, I said I want a radius of 100 miles around Xenia, Ohio, and I click map. Okay, so those 3 steps will take me now to a list and a map of the same summits that you just saw on SOTLess. So why would I want to do this instead of SOTLess? Well, partly because I've got all these names and stuff, but if you look right here, it says activations count. You click that radio button, activations count, and you click on the top of the column that has the number of activations. Now you've got this sorted list of summits, and the number of activations that have occurred. Campbell Hill is my highest with 57, followed by Hamilton County High Point, the Taco Bell one. I think it says 38. Anyway, so that tool will also help you find those quote easy summits. And I'm not, I love a really hard summit. If you give me time, I would much prefer to go hike literally a 20-mile hike and spend 5 hours on the summit. And that would be my perfect scenario. But a lot of times when I'm traveling, I don't have that perfect scenario. In fact, when I'm traveling with my wife, which is most of the time, I can't spend the whole day. She wants to be, we want to be together. And so she says, okay, why don't you go, spend 2 hours, and I race off and try to find the easy summit and get some experience in another region. Okay, so you can also, this last one is a slide actually that I showed last year. You can do the range tool to map a road route, and then do the same steps to find the summits that are along your way. So if you, in this case, we were traveling from somewhere in Pennsylvania over to the Hamvention, and we wanted to hit some summits along the way. This gives you that information. The range tool is super powerful, and once you learn it, you will really enjoy it. Okay. Well, I'm going to hold off on questions because we are running a little tight on the time. We have till 1:50, which is great that they gave us such a good amount of time. But let's hold questions. However, if you have comments or would like to add to my content, please raise your hand. I wanted to talk about the fear of missing out and the competition factor again. It's great fun to get points and to look at your stats. And I love that. I do it myself. But the important thing, and this is not just for SOTA, this is for life in general. If you're, in my case, I'm a runner, and I've learned long ago, I don't care what the other runner's time is. What I care about is what my time is. If I know I did the best I could do that day, I'm happy. That's what's really important. You're in competition with yourself. And so when you look at these stats, I want to just encourage everybody, don't worry about what other people have done, because they might have a lot more time than you. Maybe they don't have a dog to take care of. Maybe they don't have a job anymore. Maybe they've got $1 bazillion in the bank, and there's so many factors, and to compare yourself and try to beat other people can really send you down a very negative rabbit hole. So I just, I encourage you, use those points in those competitions for your own personal, and recognize others' achievements as well, certainly. But don't get into the comparison game. And then, kind of with that in mind, this is a quote from Bill Gates. And we all know who Bill Gates is. Like, I don't know if he is anymore, but at one time, like the richest guy in the world, created the system that I'm using right here, right now, Microsoft Windows, or founded Microsoft, I should say. Bill Gates' quote says, "I am not in competition with anyone but myself. My goal is to improve myself continuously." And if you apply that to SOTA, and that's the reason you want to go on lots of hikes, and that's the reason you want to score lots of points, I think you're going to enjoy SOTA a lot more than if your whole goal is to decimate the competition. Okay, enough preaching about that. And then the last thing is family and friends. So, I'm standing here, my wife is not a licensed ham radio operator. In fact, she doesn't like ham radio. She's kind of doesn't want me to do it. And that creates a real stress. Charlie and Brian are both blessed to have spouses that are licensed and go to the summits with them. If you have that opportunity to get your family licensed and active in SOTA, that's awesome. That is so wonderful. But it might not be a realistic goal for everybody. And if they are licensed and want to share it with you, you got to make sure that you don't get up on the summit and be like, I got to have, I got to make all these contacts and leave them kind of sitting there not enjoying it while you're enjoying it. So that, you know, that's kind of the best thing would be if everybody was licensed, but if they're not, then one way to enjoy SOTA still is to also do other outdoor activities. Maybe you go on a hike that doesn't even have a summit. Maybe you go do the summit, but then you also extend the hike to somewhere else or visit the lake or whatever. Maybe you create lakes on the air, I don't know. But you have to be honest about the time too. You can't tell your family, I'm gonna just run off for an hour and I'll be right back after I finish this activation, and then disappear for 4 hours. And if you plan ahead and you're honest about the amount of time it's gonna take, then everybody is on the same page and it's a lot easier. So these are, you know, again, these were just some kind of ideas about 3 of the main categories of challenges that you face as a SOTA operator and how to deal with some of those. I would love to hear more ideas from any of you, either now or later. And then that's my last slide, by the way. So I don't know if Charlie and Brian, you guys want to come on up and we can just take questions, or if you want to play Stump the SOTA activator.
Just a basic question. How do you get started? You got to register, log in, create an account.
I'm not sure that mic is on.
Submit your logs. There you go. Can you hear me now? Yeah, how do you get started? What's the basic introduction? You got to log in. You got to create an account, upload your logs. Chasers got to upload their logs. Kind of give us a rundown on how it works.
Okay, so the question is, how do you get started? Go to SOTA Data, which is the main login for creating a log, uploading a log, and tracking your activity. You don't have to upload anything, because the way SOTA works, it's not like Logbook of the World where there has to be a log to match with the other log. You just put it in, it's on our system totally. If you want to go out and activate and never submit a log, no one will ever know, no one will ever care. But if you want to participate fully, so the other person on the other end of things can see you're in their log, you should you go ahead, you create a log on, you upload your log, it'll show that you were active. And the same thing with the chasing side of stuff. You can create a log. One of the neat things that they did in probably the last 2 years, I guess, on the spotting page, when you see someone and you work them, you can actually just click on the spot. If you're logged in, there's a log there, and it'll actually put it into your log for you, so you don't have to enter it in and upload it later. In the early days, you had to have a what they call the SOTA CSV editor, because it had to be inputted a very certain way for the website to accept it. It's evolved a lot since then. So that's really all you need to do to be a SOTA activator, is just go up on a mountain that qualifies and activate it.
I would add that at the very bare minimum root level, get some gear that you think will work, and then when you do, put an alert out, and that is on the SOTA website. If you put an alert on the time that you think you're going to be there, and you have the gear, and you choose the right summit, I think those 3 things is really all you need to try it out. If you miss one of those, you might be in trouble. If you alert yourself and you go to the right summit and you didn't bring your gear, which I might have done before, then it's not going to work. Other questions? Oh, Paula had a comment or question, right?
Mic on the way, mic on the way.
There we go. Okay. Just kind of do a little bit of an extension on Keith's point, and in particular for somebody like myself from the Midwest, because we're known for so many summits, right? So one of the things that I do for efficiency is not only use some of the tools that Keith mentioned, and I found out about what SOTLess does, I didn't know about, so I learned something new today, is you notice those maps show how close everything is. So probably implicit, but let me call it out. I look for opportunities where there's a bunch of summits that I can get to and maybe reel off 3 or 4 a day for days at a time. And that's also part of what Keith's talking about in terms of easy. Don't feel like, oh, I just can go to 1. If you can drive up to 10 over 3 days, 2 or 3 days, go for it.
One in the back over there. Oh, and another one over to the right. We'll get you next.
A lot of the summits in around our area are on private land. Do you have any recommendations on the best way to approach landowners to activate the summits?
Well, I can tell you that I've done that before in Wyoming. I had to go to a plat map, I had to go to assessor's map, and I had to find the information on who the owner of the property was. And in this particular case, I couldn't find the person himself. I had to ask around town to find a contact number for the person who owned the land. But really, you've got to find the owner and you've got to ask them, and if you can get on their land, and that's the bottom line. And the only way that I found so far, and maybe somebody else can help, but the only way I found is to go to the county assessor to find out who the owner of the property is, and then either look them up on the internet or on social media, or ask around for contact information. Any other? I don't know if that's the best I can do. Over in the corner, there may be another. Are you going to add on to that? Yeah. Let him add on, and then we'll go to Dan.
You're really making this guy work. Almost every county has an online GIS system. Find the summit using the various methods that have just been described. Using GPS, find that same plot of land, or the plot of land that the trail is on that you have to use, which may be 2 different tracks with 2 different owners. But in any event, almost every county, certainly in the state I'm from, North Carolina, W4C, they have an online GIS system, and you can find the owner. And very often that person's out of state. I write paper letters asking for permission. And if I get one back, I make 2 copies. One, I take it to the summit with me in case I run into anybody. The other copy is taped to my window of my car, which says, I have permission to be here, don't call the sheriff. But paper letters are the way to go, in my experience.
Thank you. I didn't even think of that. Yeah, if you have time, a letter is great. We only have time for Dan's comment or question, and then we've got to wrap it up.
Well, thanks, Charlie. So a couple of comments. One was about how to start out, and I think one way to do is go to the map, SOTA, and see who's activated the summits that you might want to go to. And there's quite a few very active activators. Just go ahead and email them, look them up on QRZ, and chances are they'll give you some insight on how to get up there, or they may even join you. And having somebody along with you on your first activation is a great way to break into the hobby. And a few comments about what Keith was talking about. I'm not a mountain goat yet. I'm still on my way. I've been doing this for a while. And for me, it's really about the hike and getting up to the summit. And some of the summits I go on, I know that there's hardly been anybody else going up there. So really enjoy the hike and getting to the summit, and enjoy making the antennas or radios, whatever you want to do. So I know some people that have gotten mountain goat very quickly, very competitive, and then they're like, oh no, what do I do now? So just enjoy the process, really enjoy the whole thing, and that way you don't worry about not getting your mountain goat right away or being competitive about it.
Okay, thanks everybody. We'll see you tomorrow at 1 o'clock between buildings 1 and 2, or 2 and 3. 2 and 3.
Maybe one to say hi. Yeah.
Great stuff. Thanks. Oh, yeah.
Does this have internet?
Yeah, they're just finishing up.
Does this have internet?
I think so, but I haven't checked.
Yeah, I had. I've been to I think that years ago. I was using the Raspberry Pi. If it doesn't work, that's all.
Apparently it's still kicking.
How are you doing? Great. So, just another example. So, instead of going to CTU, I was writing a book.
Well, you're doing pretty good at that.
This is 40 now, right? Or is this?
Yep, soup to nuts, 4-0.
100,000 down here, done by 40 back.
Yes.
Oh, yeah. Oh, yeah, my price 4 years ago is 65. We saw the Yankees coming out. Well, I've got 10 houses. Double wide on the other side of 5 acres. My radio tower was. The HOA, I got the stealth, but it was like 5 band, we also need a lot. Top dog. Top dog. Yeah, because I had a 2-element quad made. I don't sport quad. I don't know what it is. Harder to keep alive.
Not looking so hot.
Really?
Yeah. Says I got internet access.
They had all this efficiency of remoting and everything, and then I found out I'm freaking license had stuff.
support guru is on the left there. Kid from high school is coming up. He's the guy.
Oh yeah, I ran mine. I've got some manual lines served and ran wires. But at the place we call the ranch, I got my own tower. That was the deal when we moved out there. I'm not going to go to this site. I've got 12 yards old mine because
I mean, I'll make do. It'd be nice if it worked.
It'd be nice, but we're about 2 minutes out.
Students in Lackawanna County are learning more about radio waves and their connection.
I took the 10 footers and stuff, but we didn't solid. We had, you said, well, hell, it's close enough, I'll disconnect everything. And my brother blows up. He wasn't paying attention.
Entirely covering the sun's chromosphere, and all you can see is the corona. Then you have the case of a partial eclipse where the moon is only partially covering the sun. And so if you were anywhere else outside of this total eclipse path, you would have had the chance to see this. And then there's an annular eclipse, which is very much like a total eclipse, except the moon, when it's orbiting Earth, it's not always at the same distance. Sometimes it's closer to the Earth at perigee, sometimes it's farther away from the Earth at apogee. And when it's farther away from the Earth, the moon looks smaller in the sky and can actually fit inside of the sun. So they sometimes call this a ring of fire eclipse. And that's what happened October 14th, 2023. So here are some movies I made that show the paths of these. And these movies are showing not just the path of totality and annularity, but it's actually showing the percentage of obscuration. So you can see really the entire, for the October eclipse, and almost all of the continental United States and a good part of South America had some eclipse. And my friend and collaborator, Dr. Joseph Huba, at Syntec Technologies, he runs an ionospheric model called SAMI-3, where he took the inputs of that movie, put it into his ionospheric model, and he gave us a prediction of how that eclipse would affect the electron count in the ionosphere. And we did the same thing for the total eclipse in April. So here the eclipse is going from south to north. And here's the ionosphere for that same period. So blues mean a decrease, blues and blacks are a decrease in ionospheric electron density, and then yellows and reds mean an increase. You can see some funky things happening down up and above and below the magnetic equator. Those are likely tied to the equatorial ionospheric anomalies. And it looks like my PowerPoint just quit. Document recovery.
And so you can take those model outputs and you can actually do a ray trace where you predict how an HF radio wave will behave going through that particular ionosphere. So this is a model that we ran from the 2017 total solar eclipse, going from Alpha Alpha 2 Mike Foxtrot to Whiskey Echo 9 Victor in Wisconsin on 20 meters. And here you can see at the beginning of this, let's go back to the beginning of this. Before the eclipse starts, the ionosphere is fairly strong, and Florida can communicate with Wisconsin. As the eclipse goes on, the path gets weaker, the band shuts down, the rays escape into space, the eclipse ends, things recover. So we're able to do this sort of modeling to understand what we're seeing. So we ran something called the Solar Eclipse QSO Party back in during the great total solar eclipse of 2017. And then when we saw that these new eclipses were coming in 2023 and 2024, we said this is an opportunity we cannot miss. So we decided to go even bigger, and our HamSci group collectively, we came up with this idea of the HamSci Festivals of Eclipse Ionospheric Science. We had not just the Solar Eclipse QSO Party, but many different experiments taking place. And we have a number of questions. I will tell you what these questions are, science questions. I am not going to answer all of them today. We're still working on analyzing the data, but these are some of our guiding questions. Can the annular eclipse be observed in HF communications? How large is the disturbance? How long before and after maximum eclipse are eclipse effects observed? Is there an onset recovery asymmetry observed? Do we see more what layers or regions of the ionosphere do each of the bands refract off of? How similar are the eclipse effects to dawn and dusk? Now, before I get into the results, I want to tell you about a brand new radio station, ham radio station, that we got to operate the Total Solar Eclipse QSO Party from. So I'm a professor at the University of Scranton in Scranton, Pennsylvania, and this is our campus in downtown Scranton, Pennsylvania. It's a Jesuit university with about 5,000 students, and we just had a brand new amateur radio station installed this past November, and it's absolutely beautiful. We have an ICOM 7610 and 7300. DX Engineering was kind enough to give us an ACOM 1010 amplifier. We have ICOM 9700 for satellite and Yaesu 400Ds for local VHF, UHF. We have a repeater, a 440 repeater. And all of this was thanks to a very generous grant from ARDC, almost $200,000, another $20,000 from private donors, and also support from NSF, DX Engineering, and Jeff DiPolo, WN3A. And this is all professionally designed and installed by Broadcast Sciences, Jeff DiPolo, WN3A. So this is our club president, Gerard Piccini, in the station. This is the building. So you can see there, that's where the club station is. You can imagine the view from that room looking over downtown Scranton. It is a gorgeous station. Here's our HF tower. So there's our 40-foot tower on top of a 5-story building with Jim Breakall, Skyhawk antenna, and and our repeaters up there too. We've got our satellite stations here, absolutely beautiful. So we did get to operate this during the April eclipse. And now let's see if all this, here we go.
Students in Lackawanna County are learning more about radio waves and their connection to the atmosphere and to space.
It's part of a large research project at the University of Scranton. Newswatch 16's Emily Kress tells us more about how the eclipse can change how those waves work.
It's an all-day affair at the University of Scranton preparing for the total solar eclipse. While some students are just watching, others are working hard on research.
Yeah, that's a lot of velocity change. We're looking to see how this particular eclipse affects the ionosphere and the upper atmosphere. Every single eclipse is a little bit different, going through a different path.
Dr. Nathaniel Frizzell is an associate professor of physics and engineering at the university. He says this research has been years in the making. Last fall, the university installed this tower to get a student ham radio station up and running at the Loyola Science Center. Students and other community members are able to connect with people across the country and the world.
When the eclipse comes through, it cuts off the sun and that photoionization, and so now the radio waves aren't bent the same way. And so when you receive the signals on the other end, or you don't receive the signals on the other end, if you look at things correctly, that can be attributed back to the eclipse.
Research like this is important because if we can understand how radio propagation works, we'd be better suited in cases like an emergency where, processes such as, phone lines or any other electronic communication wouldn't really work.
Students spent all day in the ham radio station since other parts of the world experienced the eclipse long before the eclipse reaches our area. The university was one of 5 chosen as part of a citizen science project with NASA. Through this research, students are helping to document history.
It's a pretty cool experience. It's like the environment and how everything is, all the people around here. It's very interesting to see all play out.
That feels pretty great, knowing that we're at the front of this, and would not have expected to have this great opportunity when I first came to the university.
Students will now spend their time breaking down all of the data collected. Emily Kress, Newswatch 16, Scranton.
So it was a really, really great experience being able to use that station. So some of the experiments, I've got 7 listed here. We have the Solar Eclipse QSO Party, the Gladstone Signal Spying Challenge, the Grape HF Doppler Experiment, the Whisper Demon Observations, the HF Time Difference of Arrival Experiment, the Medium Wave AM Doppler Experiment, and the Very Low Frequency and Low Frequency Experiments. And there were probably more going on. I know Case Western had yet another experiment going on. So one of the philosophies at HamSci is that if someone wants to try doing an experiment, we try to figure out a way to support them and get them in. So we have all these different people doing all these different observations. So here's a Solar Eclipse QSO Party. This one's the most contest-like. It has rules that read almost like a standard contest. You can use N1MM plus and to log it. So you get 2 points for CW or digital, 1 point for phone. You multiply your score by the number of grid squares, and you have an exchange. You submit your logs, but we also use additional data sources, the reverse beacon network that's automatically monitoring the CW traffic, PSK reporter, WhisperNet, participant support logs. That all gives us data for our observations. We've had 3 of these so far, the one in 2017, the one on October 14th, 2023, and the one on April 8th, 2024. And a recap of what happened in 2017, we had a total of, each network provided over 600,000 spots from RBN and WhisperNet, 1.2 million from PSK Reporter, and almost 30,000 QSOs in the participant logs. And we got beautiful results. I only ever analyzed the RBN data from the 2017 eclipse. But even doing that, this is the RBN data. We got fantastic results from that. Up on top here, this is the observations on 14 megahertz for the 2017 RBN Solar Eclipse QSO Party. Right at 0, this is when it was maximum eclipse. This all the way to the left, minus 1.5, that's an hour and a half before the eclipse. All the way to the right, that's an hour and a half after the eclipse. The y-axis is distance between transmitter and receiver, and you can see that the white curve here is the amount of eclipse obscuration present. And so you can see on 14 megahertz, the band was going gangbusters an hour and a half to about 45 minutes before the eclipse, and then it shut down as the ionosphere got weak and the signals escaped into space. And then it recovered. And we were able to model this using ray tracing and that SAME3 output that I showed you before. And we did this on multiple bands. So we were able to do this on 14 megahertz, 7 megahertz, 3.5, 1.8 megahertz. And you can see each band behaves a little bit differently. The observations are on the left here. So we talked about how 14 megahertz shut down. 40 meters, 7 megahertz went long during the eclipse. 3.5 and 1.8, they opened up, presumably because the D region absorption went away during the eclipse. We were able to model this as well, and from our models, we were actually able to tell whether the refractions are mostly from the E region and low takeoff angles, like for 14 megahertz, or from the F region for the other bands. So we don't have these, we are working on doing this sort of modeling for the current eclipses. We don't quite have this level yet, but we are working on it. But we do have some data that we can show you that is really beautiful. We also had the Gladstone Signal Spotting Challenge. This is a contest for people who operate skimmers. It's named for the PSK reporter, founder and operator Philip Gladstone, November 1 Delta, Quebec. And so we, again, had rules for that. And the basic rules were, there were two operating categories, transmitters and receivers. You could enter one or both. And the primary modes were Whisper and FST4W. And this was a no logging contest. All you had to do was fill out the form, and then we would go find the data for you. We just go up to WhisperNet or PSK reporter. We'd download the data, see who entered the contest, and we could tell you who won. And Gary McKeaton and Adarsh and Cam, W7CAM, they are all on the scoring committee, and they started processing this data. So we had 68 entrants from 12 countries there, and these are the spots received and generated just from the people who filled out our form and entered. And here's our submitted log data. If you come to our HamSci forum at 3:55 p.m. in Forum Room 2, you'll get to hear Gary AFAA talk more about the results, the contesting results from this. But this, doing this solar eclipse QSO party, we've been working on this for a while. We started doing weekly Zoom calls in September 2022, and we have a team that worked on finalizing the rules, developing websites, coming here to Hamvention, having in-person meetings, all sorts of things, print, magazines, all to make sure we could get up to this day where we could present some results. So again, come to the HamSci workshop for the contest results for the 2023 SDQP. So thanks to the people working behind the scenes on this, Gary McKeaton, AFAA, Ed Fcheck, WX2R, Mackenzie Denton, KO4GLN, Bruce Horn, WA7BNM, and the Worldwide Radio Operators Foundation, Adarsh Pashikanti, KN6VIS, Cam Cameron, W7CM, and the ARRL for helping with partnering and promotion. And now here's really the beautiful plot. This is from the total solar eclipse day, April 8th, 2024. This is all of the RBN, WhisperNet, and PSK reporter spots put together. So there's over 52.7 million data points that went into this plot, split up by band. And this is just a summary plot, so we really didn't do any hard work analyzing this, but the total solar eclipse, you could see really obviously opened up the 1.8, 3.5, and 7 megahertz bands. And I'm very confident that when we actually do dive into the data more deeply, we will actually be able to see the upper bands shut down as well. And you can see a little bite out here on 10 meters. But it just absolutely beautiful data. So that was not the only experiment we ran. We also had the personal space weather station experiment, the GRAPE HF Doppler experiment. Now the idea here is how many people know that WWV in Colorado is tied into atomic clock frequency references and is supposed to transmit on extremely stable, provide an extremely stable frequency reference? Great. How many people here know that if you actually listen to WWV with your receiver and you also happen to have a very stable frequency reference, you will see WWV's frequency vary? It does. Okay? So when you listen to WWV pretty much anywhere that's not right next to it, you will see routine variations on WWV's signal. And the reason for that is not because WWV is not stable, and it's not necessarily because your receiver is not stable, although you really need to make sure you have something like a GPS discipline oscillator to make sure it's stable. What's probably happening is the ionosphere is varying. It's changing the path lengths and the time it takes the signal to get from one place to another. So you get Doppler shifts. So like if the ionosphere were to move up, that would cause a path length increase, and that would cause the received frequency to decrease and give you a redshift. If the path length gets shorter, like the ionosphere builds up and gets closer to Earth, you'll get a positive Doppler shift or a blue shift, and the received frequency will increase. And so we now have these radio systems that, thanks to GPS disciplined oscillators, and these are little radio receivers that listen to the GPS network. They don't necessarily tell you where you're located, but they're able to provide an extremely accurate frequency reference. We can use that to discipline local receivers that can make very accurate measurements. And Case Western Reserve developed the GRAPE 1 and GRAPE 2, and we got, John Gibbons did a fantastic job on this and got all of these deployed for the Eclipses. And we also now have from Whisper Demon and the Tapper group this software-defined radio version that can listen to 9 frequencies all at the same time using RX888 hardware. And here are just some of the people that were behind all of this. We had this New England Grape group. Here's Gary, AFAA, who led the distribution. These are just a few of the people who helped out. Here's all of the data from these systems get sent to a central database run by the University of Alabama. Bill Engelke, AB4EJ, who I met here at Hamvention a number of years ago. We've become good friends and collaborators, and we're still working together today. So this is what the personal space weather station looked like for the October 2023 eclipse. And then here's what it looked like essentially today. And we had well over 100 of these GRAPE HF receivers. I think there's over 140 locations that we have some sort of personal space weather station instrument deployed. And so here's some example of that. This is from the New England Grape group that I showed you a photo of before during the annular eclipse on October 14th. So they're located in New England, and they're listening to 10 megahertz WWV. Over here is nighttime. You can see some oscillations up and down. Very low frequency receiver that listens up to about a few hundred kilohertz bandwidth. And we installed it in my backyard. It's been running there ever since. And we used that to listen to the naval VLF transmitters that are scattered throughout the United States in places like Hawaii, Maine, Washington State, Puerto Rico, all North Dakota. And again, you can see beautiful Eclipse signatures there as well in the VLF network. Rob Robinette, AI6VN, he's back there. He runs the Whisper Demon network, and he has a number of collaborators. Gwyn Griffiths, G3ZIL, who does a lot of his data analysis, and now Paul Elliott, who is, we'll talk about him in a minute. Anyway, Rob has set up this Whisper Demon network, which is an advanced Whisper decoder that it brings some new features to Whisper measurements that aren't present in the normal decoder. So Whisper Demon can measure noise, and the reason that's important is the normal Whisper decoder just measures signal-to-noise ratio. So from that measurement alone, you don't know what the actual signal strength is, you don't know what the actual noise measurement is, you just have a ratio. But since Whisper Demon estimates the actual noise, you can actually back out the signal strength as well. So you can derive the true signal strength from the SNR, and the Whisper Demon system also uses GNSS, GPS disciplined receivers, so you can actually get proper Doppler shift, Doppler spreading measurements on the FST4W spots. And so here are some examples of their observations from the October eclipse. So here is noise level on 7.04 megahertz on 40 meters. This is out at Rob's very nice receive stations in California, KFS and KPH. Absolutely beautiful sites. And so you can see an increase in the noise during the eclipse on 40 meters. Here you can see signal level increases at KA7OEI for transmissions from WO7I. So here you can see this 80-meter transmission on October 14th. You got an eclipse. You got an increase in the signal strength compared to the non-eclipse days, which are behind it. And then this is a very interesting piece of hardware that you can go see over in the Tapper booth, developed by Paul Elliott. This is a low-power, 1 watt per band, simultaneous, 8-band simultaneous Whisper transmitter that's GPS disciplined. And so instead of, it can do transmissions on 8 bands simultaneously, as opposed to scanning through them. And so now you can use, and it's all GPS disciplined. So this serves as a very excellent frequency reference beacon that we can now use and deploy around the world. And here are some examples of the Doppler shift measurements from that on different frequencies. And you can actually see the same sort of eclipse S-shaped curve in these Doppler shift measurements made using FST4W. So another really fascinating project, Steve Serwin, WA5FRF, he's retired from Southwest Research Institute, and he just loves coming up with the most novel ways to use amateur radio to sound the ionosphere. And one of the things he realized is, we can measure the refraction height of the ionosphere by measuring the time of flight, how long it takes a radio signal to get from one station to another, if you know both of the station's locations. But if you're going to make those time of flight measurements, you have to have this GPS disciplined, these oscillators and very accurate time stamping, which is beyond the capabilities of most amateurs. But he realized that if you account for multipath, so if you have a signal be transmitted from one location and it goes both one hop and two hops, they're going to have different time delays of arrival. And when you add those two signals together, you'll actually get a beat note interference pattern on the received signal. And you can actually use that beat note timing to back out the reflection of the ionosphere. And so he came up with a waveform that you could transmit over a standard single sideband channel just by feeding it through the microphone port on your regular SSB radio that will send these very short chirps, and you could look for those beat patterns and you can back things out. And so this is a pre-eclipse test, and so his measurement of height of the F2 region ionosphere is around 250 kilometers, and the red line is the HMF2 height measured by the Austin Ionosonde, which is nearby. And so they ran these for the eclipses. So we're just starting to crunch this data. We've barely scratched the surface. So the initial analysis has been performed on a 9-kilometer NVIS and a 317-kilometer regional path in Texas. And the NVIS path was directly within the path of totality. And there was good agreement between the F2 layer height measured by the TDOA analysis and the HMF2 data reported by the Austin Ionosonde. And so you could see height bumps in the F2 layer. They were observed on both paths at times corresponding to the local eclipse passage. And as you look at the more data, you see so much complexity and turbulence in it. And so there's a greater incidence of Steve has noticed that there's a greater incidence of low TDOA values suggesting greater E layer involvement than in data sets from previous years. So it's corresponding with the increasing solar cycle. And then we're seeing rapid changing between band conditions observed within the 8-second time span required to send the 10 chirps. And we're doing the analysis, and the analysis has shown the presence of differential Doppler in the different chirp data. And so, again, the data is just, it's lining up really well. So the blue data here is the Ionosonde data. The black data there is his measurement, and they're matching up really well, showing the eclipse refraction height going from, say, 250 kilometers up to 300 kilometers altitude and back down. And so he just has a lot of really nice data showing that. And so we're continuing to work on that. I have another student working on that project with him. We also had the medium wave broadcast, AM broadcast recording experiment. And so this is the idea. It's not ham radio, but regular AM broadcast radio operates in the medium wave band. And at night, these medium wave signals can propagate hundreds to thousands of miles. And because the eclipse is kind of like temporary night, you can see these effects. So Ruth Bamford is a scientist in the UK. She did this during the 1999 United Kingdom's total solar eclipse, and she has a great report you can read about this. And Nick Hall-Patch, VE7DXR, he's coordinating a similar experiment, or he has coordinated a similar experiment for our eclipses, and we've started to get some results in from that. So here's from the October eclipse. And here the KE6EE receiver was listening to KGDD and KKXA AM transmitters north of him, north of his station in California, crossing the eclipse path. And he was also listening to KVEN south of his station, not crossing the eclipse path. All were obscured. And here you can see the KKXA, so that's this station all the way up here. You could see the, you could see the amplitudes measured by his station the day before with no eclipse, and then the day of the annual eclipse, you can see a nice big increase. And then here they were using the carrier sleuth software, and they were also able to see the enhancements at night. They were able to see at least on the signal strength rise on the two stations that, because this is the day before where you don't see the increase. Here's where you do see the increase. You only see that increase on the stations that crossed the eclipse path, not on the one that did not cross the eclipse path. So there's so much more to look at. So many people are doing this. So if you want to get involved, you can go to hamsci.org. Now that the eclipses are done, HamSci is still going strong. We have solar cycle 25. We have solar flares that happen all the time. We had a huge geomagnetic storm that happened last week that I cannot wait to look at the data from. This affects our HF operating, it affects our contesting, it affects our DXing. There's so much we can learn from this. So if you want, come join us. We can show you how to set up a personal space weather station. We can help answer your questions about the science we're doing. You can help us figure out how to make this really useful and interesting to ham radio. So come join us. And I do have to thank all the people who have made this possible. First, of course, the amateur radio community, also the National Science Foundation and NASA and ARDC and all the universities, the University of Scranton and my collaborators, Case Western, New Jersey Institute of Technology, Alabama, MIT Haystack, Dartmouth, all of those institutions that are working with us. So stop by our booth in the Hertz building, or booth 5008. Come see our forum today at 355 in Forum Room 2. And thank you very much.
Thank you, Thank you, Nathaniel. Don't try to play this back at 1.5 or 2 times speed. I've been told that this is recorded, so you will be able to take a look at this. And do stop at Nathaniel's forum here later this afternoon. Which one? That one.
That's it.
Okay, it's time for our second topic here. This is 160 meters RF loss, 5/16 wave, single wire, folded counterpoise, and some antennas. Please welcome Guy Olinger, K2AV.
Howdy. Where's the clicker? Oh, space bar will do it. Okay. Just space bar. Oh, well, this is a little large. First of all, thanks to Tim for inviting me to speak on this, and hopefully I haven't done too many weird things with the slides. Also want to thank, I couldn't possibly see him in the room, thank Eric Wagner, N4RO, for the time and mental support. We had to literally create a little antenna range in our side yard, and it sort of limited the things that we could do, but if we hadn't done that, we wouldn't have these numbers here that are so important. And if you get a chance to look at k2av.com, all these people who have helped on this over the years are listed there in totally readable format. Okay, brief K2AV history. And the reason why I'm going into this is a lot of reason why people have trouble on 160 meters is they either could not afford to buy an entire farm, or they didn't even think of 160 meters when they bought their property, which is kind of what happened to me. You'll be able to see all of this on k2av.com. The history is really pretty simple. I was actually introduced to ham radio in a little city over here east called Columbus, and I had a school buddy who took me home to his house, and his father had a 75A3, a Ranger, and a home belt 10-meter ground plane on the roof. And at that time, that of course was the magical 19th solar maximum, and he was working everything and demonstrating it. And whenever he got done working stuff normally, he decided to do something interesting. He got a piece of coax and put a clip lead on the end of it, and then ran the clip lead first to some bed springs, and then worked the West Coast. And then he hooked it up to a window screen and worked the West Coast. And then he hooked it up to something near the radiator and worked the West Coast. And then he went into the kitchen and he came back with a long square noodle. That must have been home noodle, literally wet, put it on the floor, attached the clip lead to the noodle, and worked the West Coast. So I would know many years later that probably the shield of the coax was doing all the radiating, but it was many years. Anyhow, I was hooked. And so then in 1958 to 86, I went to college, I got married, moved all over the place for jobs, and see what happens if I hit this. Moved all over the place for jobs, and then at some point in time we needed to move down to North Carolina to get closer to relatives. And this should be familiar to some of you, kind of some of the reasons that we moved to a place and we can't move again. And that worked out very well, except for one thing. It didn't work real well on 160 meters. And I rejoined the Potomac Valley Radio Club whenever I was down there, and after that, I got a lot of advice. I had a 80-meter extended end-fed half-wave L up, and the guys at the club said, "Well, just use that on 160 meters. It's a quarter wave. Put down a bunch of radials, or put down some, whatever you can do." And I did that, but then my 100 watts didn't really do very well. I added at some point an AL1200 amplifier, which worked really well on the upper bands, but still on 160, even with the 1500 watts, it was hear no work. Much weaker than other people in the area with the 1.5 kW and a good thick radial field. So why so weak? Well, there were contests and experiments, head scratching. A lot of talking with other hams about what to do, and then we had kind of a light bulb event over at W0UCE's retirement place, and he folded back the 125-foot radials and pulled them all back to the center, and so instead of being 225-foot radials, we had 125 feet total of radials. And all of a sudden, he started being heard. And so I got interested in that and checked with it. The folding clearly reduced the fields at ground. And apparently, the RF in the dirt was the enemy. But his 125 foot was still in the neighbor's trees because his, and then 100 feet away on a FIM, Potomac Instruments, FIM 40. And so what we were measuring on the FCP at 10 feet with the whip over the top of it was minus 25.2. We changed from the FCP to a pair of 100-foot radials, tuned it up, got it right, and it was only 28.8, down 3 dBs. And if you go through all the calculations, which I can't do here, you will see that the difference between the two really tracks like the difference between the length, the horizontal length. Then we did it at 6 feet, got down to 32 millivolts, 3 feet, 31, but interesting, 2 inches above ground, and we were technical reasons for that. It was only 12. So the difference between 200-foot radials at 2 inches above ground and the FCP at 10 feet was 13 decibels. This is measured stuff now we're talking about. This isn't a guess, it isn't EasyNet. It's what we did in our little ad hoc antenna range. Now, the other thing that you kind of need to understand is how do you do that with folds? Well, one of the things about how these wires work is that the lowest current is at the end, right? Because it doesn't have anywhere else to go. And so what that means is that the highest current in this standing wave along this single wire is going to be a quarter wave away. Now, we've numbered the points there. That's the 16th from 0, 1, to 2 and 3, coming back to 4 and back up to 5. The current's being pushed in at 5. And the maximum current, because it's a quarter wave away, is going to be at 4. Now, I don't know if you can see that purple line or not on the monitors. Apologies for that. The numbers, this is an EasyNet display of the current. So at 5, where it's being pushed on, that's not actually the maximum current. The maximum current is over there at 4, and then it comes back. Now, notice that the currents there are about the same between 4 and 5 and 4 and 3, and then of course it starts on down and drops on down to nothing at 0. Now, I've left probably some unreadable text on here, so if somebody is looking at the slides after the presentation. I'm going to go through this, and the reason why is to understand why the folds and what it's doing. All right, current's coming in at 5. All right, current's coming in at 5. And the small arrows are simply indicating which direction the current is flowing. And in all the blue arrows, the current is flowing to the left. And all the red arrows, the current is flowing to the right. So you can see it goes from 5 to 4, and it comes over and then goes from 4 to 3, and they are equal and opposite, which means those fields are going to cancel, or almost cancel. They're going to cancel a whole bunch. Now then what will happen over when you go past 3, it's going to be starting down, and then it'll reverse again at 2, which is why the blue arrow is underneath it. But notice that the only places where the currents cancel is out at the tip of 2. So if you add up, like if you get up close to the middle and you add up the current moving to the right on 2, and you subtract from that the current moving from 2 to 1, then what you get is a net current as if there was one wire and the current was flowing to the right. Whereas over on the left side, basically the current that is left over is simply going to be what's going from 1 to 0. Now then note that what is left over is the 2 solid lines. The two solid lines are going from the center out to the end. And what that means is that this thing, the current, the effective current is behaving like 2 1/16th wave radials. And we've already seen with the measurement that this thing is better than a pair of regular radials because of the wingspan. Now, one of the things, this is from the journals thing. This shows you the power, the loss power, underneath the radials. The big one is 2 quarter wave radials, and NEC will tell you, NEC4 will tell you that underneath those radials they add up to that, and you can see that the power loss at underneath the quarter wave radials is very large. If you shorten the radials to an 1/8 wave, then you get the smaller one, you know, the middle-sized one. And if you put up the FCP, you get the little one. Now, there's a reason why one side is a little higher than the other one, and that's normal because this is a folded event instead of a doublet. It's odd. So, but also notice here that in the center, that there's a lot of cancellation. And that's because right near the center, it's coming down to the feed point, and a bunch of stuff is going left, a bunch of stuff is going right, and it cancels out. As soon as you get away from it, that effect starts to drop down. Another big thing that you can see if you look at that is that it pretty much notches out this center area, but it's not proportional to the length of your radials. It's just proportional to the frequency you're operating at. And so the notch on the FCP takes away a lot more of the horizontal percentage than it does with the quarter wave. It just almost doesn't matter with the quarter wave radials. So the FCP measured was 13 dBs better than 200-foot radials basically on the ground. That's about like giving yourself an amplifier. Now, the interesting thing about this is that if you put down enough, you're going to divide that resistance by the number of radials. So if you put down 100 radials, it will divide the number and it'll work just fine because its effective resistance, you know, is down there around 1 ohm somewhere. And 1 ohm somewhere is not going to bother you. But what do you do if you can't put down those radials? It gets to the point where you need something to do that's good whenever you put something down. You need to have something good, even if it isn't radials. Now, the things that we did, we learned a lot of things about an FCP. It wasn't just figured out all over at one time. And so a lot of this stuff came the hard way. One of the things we learned is you do not trim the FCP's last fold to tune up the SWR. Because then what you did was you moved where the end of the wire was, and of course that moves all of those nice folding things, and then it doesn't work so good anymore. So we had some false starts there. The other one was build the FCP with number 12 bare solid copper wire. And we don't have the time today or tomorrow to go into all the reasons for that. The other thing was keeping a constant small space between the FCP folds, and we finally settled on 4 inches or 100 millimeters. Then the next thing was you didn't have to have the spacing exactly right all over the place, and so some people, including me, originally put it up. I had spacers like every 18 inches, and that sort of hampered its performance. You really only need, on 160 meters, you need one at the end, one at each end, one in the middle, and 2 of them in between, and that's really enough. So use a minimum number of FCP spacers. The other thing is if the bushes or the weeds or the swamp grass or whatever it is grows up into the FCP, it really starts to get lossy. And so we figured out that actually by doing some measurements that you need to keep a 5-foot radius around the FCP, clear vegetation. And so that means that every year you need to go in and do a little cleanup. And the other thing was avoid nearby miscellaneous conductors. So a fellow put up some 80-meter versions of this, and he literally nailed it to the house. and he had a metal siding, and that didn't work so good. The other, do not mount the FCP to or close to tree trunks or root parallel or close to any sort of long wooden beams. Always elevate the FCP 10 feet above ground if at all possible. And there's a lot more, but this day will not permit. Going past, wondering how hard it was to break free from the traditional thinking. I had a wonderful Elmer in Corbin, Kentucky, W4IQZ. He was the chief engineer at WCTT, AM station, I believe. It was on 640. And so he had a huge, huge tower up there. It was 500 foot. It was a 150-degree tower and 150-degree radio field. Had he told me, I think he told me 200, but that was my understanding of how all that stuff works. And that very nicely took care of their problems, and that was really a very well heard station. But an antenna's aerial conductors are intended to produce maximum possible RF radiation with minimum losses. And then the counterpole, or whatever we're using as a counterpoise or a radio system, the design of that is intended to produce minimum possible RF radiation with minimum losses. Well, RF radiation can be soaked up by the ground. It can be soaked up by being next to a tree or in woody land, and you're not going to have minimum losses. But whenever we go to put something together like that, we're not thinking about that minimum RF radiation with minimum losses. Maybe we're worrying about dB slices in the aerial and ignoring piles of dB in the counterpole. In my case, that's exactly what I was doing, is when we were doing that before we finally came up with the FCP, is I was ignoring 13 dB of loss in the counterpoise. Then the other thing is that you look at it, we monkey with the design in the air, and what we want to do is to make the feed point easy. Well, feeding an FCP is not easy. You have to come up with an isolation transformer and change links and that sort of thing to get to use it. But the reason why we did that before, you don't have to do anything, you just buy this thing, put it up in the air, and screw the coax to it, and it works right then. But what if that limits your design possibilities? Within some limits, what if with the only time, let's just put up an antenna based on the best design and accept the idea that the feed point is miscellaneous and you're going to have to do some matching. You might get lucky and just hit it and don't have to do anything, but chances are, and this is definitely true with an FCP, that if you put up a quarter wave and then put up an FCP under it, that it's not going to be resonant. You're not going to be able to put that together and just feed a quarter wave of coax to it. Well, other thoughts? Now this is where we get into new ways of looking at antennas. You'll notice that the arrow up there is just the best direction. But you will notice that there are no radials on this thing. There's no FCP, there's no anything. Actually, I'm working on this antenna, and it's a little tricky to figure out what the links are, but we're going to get there. You need positive polarity on the slanted line at about 50 ohms relative. We'll just use that. And then on the bottom one, you need the opposite polarity at 200 ohms. And that creates a pattern. Well, how do you do that? How do you do that with a piece of coax? There's no way in the world, because when you hook a piece of coax up to something, the impedance that's coming off the coax is the same on the shield as it is on the center conductor. But what if this design, and I'll tell you what I've got so far, is in the main direction, it's about 2 dBi. And part of the 2 dBi is because it doesn't have to worry about ground. Now, in order to get that, well, I don't know how to feed an antenna with one of them at 200 ohms and the other one at 50 ohms acceptance. And so you have to do that with transformers. But what if, when you come up with something like this, you've already made the decision that I'm going to put that up because the wires have that gain. And then the next thing I'm going to do is figure out how in the world to make a network to feed it. Design first, feed last. But we don't do that these days. So you would never get to this antenna. And this also has a good front to back, and It's intended to be mounted to a tower without seriously inducing the tower. And there are a lot of multi situations where that's really helpful. Or the other.
And gone, he still sort of model files, AO, YO, the Brian Beasley programs, Yagi Windows, neck wires, MMA&A GAL, 4NEC2, even it accepts 2 of the mechanical Yagi programs, Yagi Mechanical and Yagi Stress. So those can be read into AutoEZ. And then, of course, it'll drive EasyNEC with them, right? So it's sort of a free conversion to EasyNEC from these other tools. Okay, now an EasyNEC model is built from numbers and choices in a bunch of tables. And I counted them, I think there's 8. And things like wire sources, loads, or tables. And EasyNEC did evolve to include a lot of very powerful commands to let you edit, especially the wires, in a convenient way. But of course, a wire is described as 2 endpoints in space with an XYZ coordinate. And a lot of what turned people off about modeling is, how do I figure out those numbers, right? So many feet over this way and feet, this sort of thing. And I think that turns a lot of people off. But in the old days, that's what you had to do with a calculator. Okay, let's look at an inverted V here. It's a nice example. Of course, there's reasons why we don't need to talk about why people might pick an inverted V just in general. Although if it's close to the ground, we know that it's probably a cloud warmer or an NVIS sort of antenna. Okay, I ripped off this picture from the K7MEM website, and here's the picture of our inverted V. We have an apex height. We have, he calls it the apex angle. I somehow like to think more in terms of the drop angle, which is the angle from the flat top down to the wire, which of course would be 180 minus the apex angle, that quantity divided by 2. You have the dipole length, each half, and we're going to model this at 80 meters at 3.525 megahertz. So here's, of course, where this is what turns people off about modeling. You got to get into usually some high school trig at some point. But we have an apex angle of 90 degrees, drop angle is 45. That puts that center point at 0x, 0y, h feet off the ground. And let's start off with 50 feet. And of course, it's going to be symmetric to the other side of the y-axis. Okay, and then there's the typical trig formulas. Now in EasyNEC, and this may be hard to see back too many feet, so, and in fact, worse than that, will my pointer go here? We have here's the wires table, right? So there's 2 wires, and each is 1/2 of the inverted V. Each one begins at 0, 0, and 50 feet. And then they go off. We're all in the YZ plane, so the X dimension is 0, and they terminate at 47.3 feet and 2.6 feet off the ground. That's number 12 wire. Okay. Then the source table, that's where we're going to excite the antenna. That just says go to number 1, wire number 1, the end of it 0% of the way, and put in what was called a split voltage source. Now it turns out, for example, in NEC 5, you don't need split voltage sources. So if you had a bunch of old NEC 4 models or NEC 2 with split sources, which is how you had to do it back then when you wanted a source where wires met, NEC 5 doesn't have that. So that's one of those little tweaks you would have to make. Now, where did that length come from for the 2 side wires? What I did to make my life easy was I started with the flat dipole at the approximate length up at 50 feet. And I simply fiddled with the end length and tipped them down until I got it to resonate, 0 reactance. And then I used some very nice EasyNEC commands to tip the 2 wires down to a 45-degree angle each way, which leaves the 90-degree apex. And then, of course, once that was done, the resonant frequency changed a little bit, so I fiddled again with the length to get that resonant again. But it took a few minutes. I didn't have to break out the calculator. I didn't have to break into a sweat. But I had an EasyNEC model. Now EasyNEC, or AutoEZ, presents nearly the same tables, but now the spreadsheet cells can contain variables and formulas as well as numbers. So here's what the AutoEZ model looks like. There's some convenient constants that it provided at the top like 2 pi, what a half wavelength is. This particular model is all in feet, by the way. So a quarter wavelength is 69.75 feet. But the big thing are the 3 variables. And again, it's hard for me to, my pointer here doesn't work, but the A variable is 50 feet above ground. The B variable is that 45-degree drop angle. And the D variable is the 66.7-foot side length, which came from EasyNet. So if we look at the AutoEasy wires sheet, notice it looks pretty much identical to EasyNet, right? We have 2 wires, each one has the same end, and then they have the different Y-direct dimensions. So of course, at this point, you could say, Greg, what's the big deal? This just duplicates EasyNet. You're wasting my time, buddy. Okay, but notice that little formulas button with the red arrow. So if we click on that, now we go to a version of that same sheet, but now we're like in formula mode, and there's that big red cell there to tell us that, in which now what we can do is put our formulas and variables and formulas with variables into the cells in the spreadsheet. So for example, notice that the height on end 1 of both wires is equals A. And A, if you remember, was 50, the height of the apex. And then over on the end 2 of the wires, we have the formulas going back to using sine. Of course, most all computer-related trigonometric functions use radians, not degrees, so you got to convert that in there. But in any case, now we have a parameterized model, right? Then we can go to the calculate sheet, and of course, AutoEasy is in Excel, and it's organized as a bunch of sheets, right? Now, I sometimes call sheets tabs, but I think sheets is the official Microsoft word. Okay, so for this guy here, we have one frequency, our 3.525 megahertz on the left. After doing, of course, calculate all rows, we see the resistance there, what is that, 49.13 ohms. The reactance is pretty much 0, so it turns out we're going to have a nice low SWR, which is one of the advantages an inverted V has. The maximum gain. Now, another nice thing about this is I clicked on including 3D data in calculations, and I also clicked in the far right, include the average gain test. If you're into modeling, one of the things that comes up sooner or later is this notion of the average gain test. And the idea is to make sure that you've got the most reliable and trustworthy modeling results. And that's done by doing this average gain test. And that largely looks for gain either escaping or artificial gain showing up. So you want that to be very close to 0 dB or an average gain factor of 1. So this is pretty good. And if you notice, the elevation angle of maximum signal is 90 degrees, so yes, this is a cloud warmer. So of course, now all this data is available in EasyNet. So once again, you might say, Greg, you're wasting my time here again. Well, now we can go to the generate test case dialog. And in this case, I put in a frequencies from 3.5 to 3.6 in 5 kilohertz step size. That's 21 total steps. And then you click OK. And then you end up with this. So what this represents, each line is AutoEasy running EasyNet once, capturing all the results, sucking it up inside, and filling up all the tables and everything else, okay? So this I would have had to do historically by myself and, write the numbers down, and if I wanted to make graphs, do it. Now, in all fairness to EasyNet, EasyNet for many, many years has let you sweep SWR. That's it. If you wanted to sweep gain, now another sheet that's available is the pattern sheet. And as you can imagine, this shows your elevation azimuth patterns for the slice you're interested in. You can also click on a button up here and get the 3D plot as well. And of course, if you, in the middle there where it talks about test case, we have 21 separate test cases here, so you can move through all the slices. There's also a lot, on all these windows, there's some very good commands that let you add legends to graphs and copy them to the clipboard. So if your goal is to write a document or, save your data somehow, this makes it a lot easier. Okay, another sheet, another tab is the triple sheet. And here there's 3 separate graphs here, hence the name triple. The one in the upper left is the R, or the resistance and reactance at the first source. Now, a model might have many sources. The inverted V has one, so we don't have to worry about which source are we talking about. But if we had more than one source, you could pick which one you want to investigate. But that shows the R and the X. And if you notice, again, I'm sure this must be impossible to see, but at 3.525 megahertz, the reactance crosses 0, and the resistance is right about 49 ohms. The gain is in the upper left, and then that SWR curve is in the lower left. Now, there's also a Smith chart tab for those who are into it, but we're not going to show that here. Now, rather than vary the frequency, let's hold that constant and instead vary the apex height. Remember, that started at 50 feet. Let's go from 50 to 120 feet off the ground in 5-foot steps. So the way we do that is, going back to generate test cases, we now can add a variable, A. And notice how it goes from 50 start value to the stop value of 120. The step size is 5. We're working in feet, so there's 15 steps. And over on the frequency side, that's the start and stop are 3.525, so that's one step. Ultimately at the end here, you could fill up with 3 variables here, but when you think about it, if you had 3 variables, each one did 10 steps to investigate some part of your design, that's what, 10 times 10 times 10 is 1,000 models you would run. Now, EasyNet will do, or AutoEasy will do it. Maybe it'll take 5 minutes, but go off and have a cup of coffee. It'll run it all for you, collect the results, and let you analyze them. Okay, so with that, here's the results. Notice that the frequency column on the left is always 3.525 because we haven't changed that, but the height goes for the A variable from 50 to 120 feet, and then we can see what happens to the resistance and the reactance. The SWR, of course, turns out that it goes up. The max gain goes up. The takeoff angle of a maximum signal, though interesting as you would expect, drops from 90 degrees when the V is very close to the ground, a cloud warmer, down to 38 degrees. So again, EasyNet could let you do this. You just be running the model 15 times and writing it down and maybe making your own Excel graphs. Now you don't have to do that. What if I was thinking of putting the apex at 50 feet? Okay, now what would I have to do to change the length to bring that into resonance? So here I selected 3.525 at the A variable is 80 feet, and the D variable, which I wasn't changing, but I included it here, is at 66.76 feet. If I click on that button called Resonate on Selected Cell, what that tells AutoEasy to do is you are allowed to change the value however you have to in that cell until the reactance goes to 0, right? So we're going to resonate the antenna, or that source to be particular, specific, by changing that variable. And that's the D variable is the length of a side. So we do that, and it turns out the answer is 68.59 feet. And then if we look over here at the resistance and the reactance in the highlighted columns, 54.23 ohms and 0.03 ohms of reactance, or 1.085 low SWR. So again, we let AutoEasy do that, right? If you remember, what I said earlier was I was fiddling in EasyNet, changing lengths to get things like reactance to go to 0. Here I let the program do it. Now, instead of just selecting the one cell, I could select all of the cells in the whole D column and click on that Resonate on Selected Cell button, and now it ran EasyNet as many times as it needed to and fiddled with the length to bring all of the reactances down to 0. So here's a table of an 80-meter inverted V resonant at 3.525 megahertz with an apex height from 50 to 120 feet with all the lengths calculated for the lowest, or to be resonant. So they go from 66.76 feet at 50 feet to 69.43 feet at 120 feet off the ground. Let's see here. You could also, of course, experiment with the apex angle, right? That drop angle. So in this case, I got the apex height at 80 feet. The 45-degree drop angle is sort of where I'm starting. I've got that length. But now when I go to the Generate tab, notice that I'm varying the B variable, right, which was that drop angle from 10 to 60 in 5-degree steps. and then we get the results of that, and it ran it all itself. There's another very powerful sheet called the custom sheet or graph. And here, when you think about most graphs we generate in modeling, the x-axis is frequency. But oftentimes we want to look at other relationships between variables. So here, this shows the relationship between the maximum gain on the y-axis, and then the x-axis is the b variable, which is that drop angle going from 10 degrees, meaning it's almost a dipole, right? We've only dropped 10 degrees in each side, down to 60 degrees, which we understand is going to be a bit compromising. And you can see the gain drop from about 6 dBi down to 4. And there's a snapshot button there that lets you save one graph, run AutoEasy again, and compare it against it. So again, this is stuff that we could always do if we want to just write down numbers, put them in Excel ourselves, and take the time. This graph compares 120-foot apex to an 80-foot apex V using that snapshot feature. Okay, some talk here about optimizing models, because this, I think, is a lot of fun and a lot of the power of AutoEasy. I think it's fair to say optimizing antennas is oftentimes more of an art than a science. This makes it fun. If we say optimize, we're optimizing something, right? We're not optimizing thin air. So you need some initial design, but that can usually be a reasonable guess. AutoEasy uses something called the Nelder-Mead simplex algorithm. There's details on one of Dan's web pages, and it also has its own Wikipedia page. I went into some detail here now that I'm going to skip about some of the pitfalls of optimizers, but one of the reasons why Dan picked the algorithm that he did was to, as best as possible, avoid some of these pitfalls. The main concern is you end up in a local minimum, right? You tell it to optimize the design, and it does, but it's only sort of in a part of the design space. But it turns out if some other part of the model was more radically different, it might have to do. That's a lot of stuff. There's a lot of optimization algorithms. Dan did spend time trying to figure out the best algorithm. He used a lot of the built-in ones in in Excel and found them lacking. Let's here now talk about optimizing an OWA Yagi. I, over the last 10, 12 years, have been involved in probably about 20 OWA designs and optimizations. And we're looking to see, can we optimize them? Another thing that sometimes happens is somebody wants to redo their Yagi, but with a beefier taper schedule, right? They want to move to bigger tubing, have a higher wind rating, but now you've got to go and re-opt improvements, of course. They're relatively small, but it can do it. AutoEasy never gets stuck like, I think that applies to optimization as well. This is a 6-element, 20-meter OWA Yagi on a 48-foot boom. And of course, if you know anything about OWA, optimized wideband array, you bring that D1 director close into the driven element, closer than you would if this were only a traditional Yagi, and that forms that coupled resonator that leads to a wider SWR response. So here are the variables for it. There's 13 variables. The offsets down the boom and the tip lengths. And AutoEasy, of course, will be adjusting the tip length. Maybe you don't want to optimize all of them. We're not changing the height above ground, right? That's fixed, 120 feet. Of optimization objectives that you assign weights to. And that's, for example, where we see SWR and gain and front to back and front to rear. So by adjusting those numbers, you're putting in how much emphasis you want the optimizer to put in to improving that quantity, that quality. And then you turn it loose, and it's a lot of fun. I think it is, watching it do its work. Oftentimes, and you'll see the trade-offs, right? Like in cases like this antenna, you can get that SWR insanely flat, but you'll see the gain drop a little bit, right? And then you say, well, gosh darn it, now it's not as much gain as this other SWR graph. Even though it looks high, the highest SWR there is like 1.16, right? So it's still relatively low, the gain, the front to back ratio. Well, I'll say one more thing here. I guess we're about 350 here. Really, a lot of people I know have what I would call an aluminum tubing boneyard for any band you want. Use something like Yagi Mechanical to get the strength at the end. And now this is the end. Thanks.
Thank you, Greg. This presentation plus the other two that were here, and stay in your seats. You don't want to miss the legal forum, which is coming up next. So until next year, 73.
It's really good to see you. That's terrific. David, I was back and forth with several guys commenting on the fact that everybody knows who AC0C is. Yeah, they're always saying that. Great. Have a good one. Thank you very much. Great to see you. Yeah. Right, right. The personal wireless. Actually, if you want to, I can go first because I'm going to whip right through it. Okay. Up to you. This is your form, as far as I'm concerned, because you're the guy. So, I've been here forever and I'm respectful of that. Yeah. So I'm going to, he's a good guy. I've known him for years. Yeah. Go ahead. Sometimes it's good to put a face joint. It'll say black, micro black. Think otherwise once in a while. And I'm gonna do PWS this one, and he's gonna do that one. Hey, wait, before you do it. I have what I thought was the latest version of yours. Yeah, the one you did is what I'm using. So then it's all, then I'll put it on here. We don't have fun. Excellent. Just open it, make sure it opens too, both of them. Let's make sure they both open. We want these duplicated, right? Yeah. We're talking about we're recording it. We're talking about recording. Hi there, neighbor.
And there is a wireless microphone here for Q&A.
Yes.
If people need to grab the microphone.
Why don't you we'll come. My experience is that with this fan, I can't always hear what they're asking. Mm-hmm. So when the talk is over and I leave the computer, I come down, I take the wireless, and I go out. I'll leave it here. All it is. Hold on. It's a screen. You're on. Sandy, bitte an den nächsten Raum. Dabei. Hi, everybody. We're going to start on time because I know a lot of people have to go and change clothes, get showered up, be prepared for dinner. Something fancy, I'm sure. In any event, I'm Fred Hopengarten, K1VR, and we're going to talk about, every year at Dayton, we talk about different topics. We never talk about the same thing twice. And this year, I'm going to be talking about the subject that comes up in a lot of local ordinances. If you're out there looking to get a permit and your town has a wireless, has a personal wireless services ordinance or a wireless communications facilities ordinance, generally caused by the Telecommunications Act of '96, which is the advent of cellular telephone. So PWS, personal wireless service, WCF, wireless communications facility. What's the difference? There's no difference. It's just the wording that your town chose to put into the new bylaw that they passed sometime after '96, usually before '98, '99. And the real problem is that they generally, when they were drafting these things, they always have a definitions section. And the definitions section sometimes reads something like a device which can transmit and receive radio signals. Well, that means your baby monitors and TVs and your cell phone are all included. And, so when someone pointed that out to a lot of these towns, they said, oh, and requires an external antenna. Well, that means that your car and your boat and anything else you have a radio on is also included, and you might have to get a special permit for that. Well, obviously, they never intended that. It's just sloppy drafting. Now, I want to tell you, every lawyer on the planet is a great lawyer and a good draftsman, but it's just not true. It's what I want to tell you, it's just not true. So let me begin by telling you a little bit about me. This is the pitch where I say, you know, you really should be a member of the ARRL, especially if you're going to call one of us who's a volunteer counsel and ask for help. You know, it would be nice if you're a member of the league when you're asking for the free help, because it's a member benefit and you're not really entitled to the benefit unless you're a member. I hope you can follow that logic. In any event, I am a volunteer counsel, and as you'll see by the certificate for, that says full member on the far side of the screen, I've been a member since 1956. I'll give you the rest of the hour to do the arithmetic. And I do support the league myself, and I'm a member of the Diamond Club, and I hope you too will contribute. In addition to the talk I'm going to give today, I have recorded a 6-part series on antenna zoning for the ARRL webinar system. And I know that you can't read the entire URL, nor am I going to read it for you right now. But if you want to find it, you can dig it out on the ARRL webpage whenever it comes up. And if you don't do that, you can always just send me an email and I'll forward you this presentation, including all the URLs, which are in type too small for you to read from the audience. So let's begin with a typical ordinance that is actually somewhat well written. And I'm giving you real examples that have the examples I'll be giving have all come up basically within the last year for me. In Medfield, Massachusetts, WG5I asked me to look at their local ordinance because he had been told that as a result of their personal wireless service ordinance, he could only put up a tower that was 40 feet tall. Well, it turns out it isn't true, but it sure looked like it to the building officials because they began by taking a look at the definition of a personal wireless service, and it says radio communication services specifically identified as personal wireless services. Well, it sounds like they were doing a good job, only PWS, personal wireless services, is not exactly the wording that the FCC used. It's just the wording that the local lawyer decided to use. However, they were kind enough to go on and give us a good hint, because such services include cellular, personal communication services, enhanced specialized mobile radio services, among others. There's your problem, because sometimes the locals say, well, ham radios among others, isn't it?
The answer is no, but you wind up with bad drafting causing a lot of heartache and grief. However, let me just say that there's also more than one place to look for definitions. I was looking initially at personal wireless service, which I thought was helpful, and then I looked at personal wireless tower. So you walk in, you say, I want to get a tower, and they look at tower first, and then they get misled because the definition of personal wireless tower is personal wireless antennas at a personal wireless facility. Well, you have personal wireless services defined and you can live with it, but you don't have personal wireless facility defined, and that certainly begins to sound like the other widely used term, wireless communications facility, which is a term defined in the 96 Act and specifically defined. So let's take a little bit of a look at the Federal Act, which specifically identifies personal wireless services, PWS. And it means commercial mobile services, unlicensed wireless service, and common carrier wireless exchange access services. Well, you really have to be an FCC lawyer to enjoy that kind of writing. But common carrier wireless exchanges is sort of hearkening back to the days of plain old telephones, if you remember those days. Is there anyone in the room young enough to be confused when I say, in any event, you do get these cross definitions. The term personal wireless service facilities means the provision of personal wireless services. Okay, so the question became, does it apply in this particular town? And you know, we have hundreds of thousands of cities and towns. I can't read them all to you in a 1-hour talk or a 5 or 7 minute talk as this is, but I'll give you an idea of what this particular one says. And it says, it provides you with an out, as it were. First of all, in this particular town, we've managed to get out because even to the dumbest planner, and no comment further, you can probably convince them. Say again? But I duplicate myself. The next place to go is, don't think of yourself as a personal wireless service facility or wireless communications facility or a personal wireless tower. Think of yourself as an ordinary accessory use. But they weren't kind enough in this particular town to use that very common phrasing. Instead, they decided to call an ordinary accessory use a necessary, pertinent structure. You know, why use a common phrasing when you can use an uncommon phrasing? But in this case, we happen to have the benefit of the fact that it actually includes communications tower, mast, antenna, aerial. Now, I'm looking for the engineer or lawyer who's going to help me distinguish and answer the question of why do they have an antenna and an aerial. If you have a good idea, please tell me. But I tell you that it's more realistically sloppy drafting. Now, here's where there are two more parts of this particular accessory use section that invite you to do some investigating. Number one, is your ham radio communications tower, mast, antenna, or aerial a necessary appurtenant structure? Now, in my case, what's necessary is a 100-foot tower. But somebody might decide that what you want to put up, perhaps more modest, perhaps more extravagant, is not a necessary appurtenant structure. The way I attack that is I go to W1UE, who will produce a study on with propagation maps of the kind that you see in cellular telephone service, telling you about what the coverage opportunities will be with your tower. And basically what we want to do is prove that to you as an individual, 75 feet, 125 feet, whatever it is you are thinking about is necessary for your purposes because you are the person that counts under PRB1. It's a subjective test. It's you, not some rogue ham who thinks a dipole at 12 feet is adequate to communicate around the world when the sunspots are at 228. What we're going to be talking about, though, is the rest of the sentence, which deals with the setbacks. And here's where it drives me crazy, because it says that the setback shall be increased 1 foot horizontally for each 2 feet of height exceeding the height permitted in the district. So you've got to parse that literally word by word. And here's the way you'd kind of do it. In fact, I think I may have an example later, but basically you're going to take the permitted height, and let's say the permitted height is 50 feet, and you want to go to 60 feet. So you're going to go up 10 feet above the permitted height, which is going to increase the setback by 5 feet. Nobody's with me. I see blank faces. Okay? You're with me on the math. So this proves to you that even if you go to law school, you still have to remember a little bit of arithmetic. Now, I've described to you what I think will be the necessary appurtenant antenna in this particular town for this particular radio amateur. But there are some little tricks to that. First of all, when you go in, look at what an appurtenant structure is, they don't actually define it in this particular town's bylaw. In many towns, an accessory structure is well defined, and it's easy to say ham radio's an ordinary accessory use of a residence. But you don't know what an appurtenant structure is. You got to go searching around for a commonly accepted definition. Fortunately, the insurance industry has looked hard at the question of what's an appurtenant structure. And FEMA, the tiny little lettering tells you that I got this definition from the Federal Emergency Management Agency. It's a FEMA.gov website. It says that an appurtenant structure is a building of lesser value, in other words, it's not the principal structure, located on the same premises as the main building insured under a property insurance policy. Now, it turns out this is both in conflict with federal law, but still very helpful to you. And the reason is, under PRB1, you're entitled to put an antenna on an otherwise blank, empty lot. This, however, would require you to build a house in order to put up an antenna, which seems to me like a classic case of a very large tail wagging a big dog, or however you want to use that phrase, because you have to have a house before you're allowed to have an antenna. This also means that if you happen to own 2 lots side by side and you want to put the tower up on the next door lot, you've got a problem if you're in Medfield, Massachusetts, unless you convey the second lot to yourself and make it all one big lot, which, depending on the city or town you're in, may increase or decrease your taxes, your personal, your real estate property taxes. And now I said, I promise you I do the calculation. Basically, setback goes up 1 foot for each 2 feet of height that exceeds the height in the district. Well, you go to the table of height and bulk regulations, you find out in this particular town, in this particular district, the height in the district, maximum height is 35 feet. And the setback in the district, now you just have to look at only one of these because you're only going to look at the closest setback. You don't have to look at them all because only the closest one is applicable. So in his particular situation, we're going to put the antenna in a spot in his yard where 15 feet is the closest setback. So for a 75-foot tower, which is what he wants, if the side lot line closest is going to allow 35 feet plus 40 over 2, 35 plus 40 being the 75-foot tower he wants, that's 20 feet of additional side lot setback for a 75-foot tower. You add 15 feet of side setback to 20 feet, and the new setback will be 35 feet, which is no problem in his particular situation. The actual numbers in his particular case are not the takeaway. The point is, you've got to read this stuff word by word to figure out how much you're allowed to have before we get into a fight about whether or not they have limited you to a firm fixed absolute maximum height, which is probably illegal in a lot of states and a lot of circuits of the United States Circuit Courts. Now, here's another example that just popped up 2 weeks ago in Kootenai County, Idaho. We began by looking at the definition section. A lawyer I know once told me he would allow a client to sign absolutely anything as long as he got to write the definitions and the effective dates. And here's an example of a definition being helpful. A wireless communications facility in Kootenai County, Idaho is this broad definition: any facility designed and used for the purpose of transmitting, receiving, or relaying voice and data signals. And again, I suggest to you, that's a baby monitor, a television, a radio in your bathroom, and you might need a permit for it.
The law provides we might fund some of those cases. Now, there are guidelines. We can't pay for all of it. Lawyers are just too damn expensive, and we just can't use up the members' money spending the kind of money that for major cases that are required. But we can help. And as I said on this slide, the fund that we have specifically allocated for the Legal Defense Committee comes from you folks. Thank you. There's a separate fund when you have been solicited with postcards or however we're trying to get extra funds this year, or whenever we do it. You'll see, please donate to the Legal Defense Fund, Spectrum Defense, whatever other program we have going. And as we talked about already, we have criteria, rules, and procedures for spending your favorite dollars, because this is really your money. Who in here is an ARRL member? I didn't ask that. That's like everybody. Well, thank you. That is, with one or two exceptions, everybody. These are your favorite dollars. So I want you to know what we do with it or what we plan to do with it. First of all, these things on here, I don't know if you can see it on the monitor. This is just sort of an outline. Naturally, the activities we can fund may have to do with antenna height and placement. And traditionally, that's the one that we have been doing for many years. We've been going after that. This is one you may not be aware of. We're also charged with funding matters that are interference allegedly caused by amateur radio operations to non-amateur radio users and services. We used to call it, back in the day when my hair was black, TVI. Most of you remember how everything, especially if you lived in a town with Channel 2 or Channel 3, and especially like me when I was a kid, 13, running 6-meter AM when I got my technician up from novice, a general soon after. I used to interfere with everybody. And I had a Miko TX62. It wasn't a bad radio. It didn't really have any junk coming out of it, but every TV front end, the rest of that story. Thank God for cable. By the way, interference received by amateur radio operations from non-amateur radio sources. And we might also include that to mean potential interference. How many here know what I mean when I say BPL? All right, good. Broadcast over power lines. What a wonderful idea. That's right. I'm sorry. Thank you. Broadband over power lines, which sometimes would be broadcast too, the digital broadcast. But yes, broadband over power line was the worst idea known to man, because they're using single wire, really, to put a lot of RF in and hope that a few miles away some will come out at frequencies, and most of that energy, as you folks know, probably radiated all over the place. We were in real trouble, and I could tell you, this is back in the early 2000s, was it? It was a while back. I lost sleep over that because I knew exactly what was going to happen, and many of you did too, and the nonsense was going on. Well, I'm here to tell you that this kind of activity by your league prevented that. We lost in district court. We appealed it. The circuit court spent hundreds of thousands of your favorite dollars It's a lot of money, but it worked. And it really was important that we did that. People don't like that this stuff costs that kind of money, but I'm here to tell you, those of you that have had RFI issues in which it blanketed the whole HF and some VHF spectrum at 20/9, that's the world we are going to live with. It was more important, apparently, politically, to get cheap internet connections to the masses through your power wires going through your neighborhood than to worry about amateur radio. We had some allies. We had the military, and the Boeing aircraft thought it was a bad idea because of HF radio and all that kind of stuff. We also look at RF safety, structural things, environmental, other matters found by the committee. I'm chairman of the committee. We've got about 6 lawyers on there. Found by the committee to involve and potentially impact hams. That's what we do with your money. Now, funding is limited to activities predicted to provide assistance significantly useful to others. And what that really means is that we can't put money in something that's just going to benefit you but nobody else. That just wouldn't be fair. We couldn't do it. We'd run out of money in about 2 months. We're doing that. We will pick cases that look like if we win this one, this is true all over the legal field. When you have precedents, you pick a good case and say, this needs to be decided. We're going to put some resources. The facts are good. That's very important. There's no bad witnesses are going to show up and really kill us. You have something to push and make some precedent. So here's in descending order, the kinds of things that your committee will fund. First, we like appellate level cases on the national scope. I was involved in one in the Third Circuit. Went for 3 years up through the zoning board of some significant township in the greater Philadelphia suburbs where I live. And we had 5 nights of trial. I had 110 trial exhibits, and we had 500 pages of transcript. This is at the zoning level. And we appealed it to the federal court, who didn't like us very much. And that we thought that was wrong. We appealed it one more time to the Third Circuit Court of Appeals, who gave us a decision that even the legal review of the Pittsburgh Law School, I forget which one, but University of Pitt wrote an article on it and said nobody can understand this decision. I thought it was just me, so I felt better. And we transferred the case, as procedure allowed us to do, to the state court, because we had state court issues. When you sue, you throw everything in, count 1, count 2, count 3, and whatever else you can think of and allege without breaking a smile. The lawyers know what I mean by that. And we did that, and it went to state court for Third Circuit. Took a couple years, and we transferred it to state court because we still had state court claims, and that went to the trial level. And they threw that out before trial, then went to the next appellate level, and then we went to the Supreme Court of Pennsylvania, and they said, no, but thanks for asking. So those are the kinds of cases that can be significant. When they're way up at top, they will affect all of you in that general area. Appellate level cases of statewide scope. Trial level cases are important, but you can win or lose a trial level case, and it's not precedent necessarily. It's persuasive, if you know what I mean by that, but well, of course you do, but it's from a legal point of view, I mean. And initiatives involving laws, bylaws, regulations which impact ham radio operators deploy effective antennas. That's kind of a catch-all. Did I skip something? No. Funding limitations, you should know this, not more than $10,000 per activity, so as to maximize the number that can be funded. We don't want to spend all of your money on one case unless it's something like BPL. The stuff that kept you up at night, I'll bet, too. If you were paying attention back then, I think some of you were. But $10,000 per activity, and limited to the amount of legal research and resource fund. In special situations, we can override that, but we have to be careful. It can be waived by the executive committee of the ARRL. It's somebody above my pay grade. And by the way, we don't get paid. I wanted to spell that. Directors don't. Somebody told me today he thought we did. And as volunteer counsel, we don't get paid either. Now, for a particular antenna installation, you're denied a tower or the things that Fred told you about. And by the way, I handled a local matter in which this WCF that he was talking about is starting to become a real pain in the you-know-what. It's really becoming an issue. And I use some of the arguments he has. In Pennsylvania, we also had an overriding law that threw them for a loop, but some of the states don't have stuff like that. And PRB1 just isn't, is a paper tiger. I'll talk about that in a minute if time permits. But the case must have substantial merits on the facts. You know, if you want to put a 200-foot tower on a quarter-acre lot, I'm not sure we're going to talk to you at all. We're just going to ask you to reconsider. And if you were able to pull it off somehow, I'm going to invite you to all my parties. That's just not going to work. It's not reasonable to do that. If you live on a small lot, you know, you can have maybe a 65-foot tower. There are people that want higher towers, and some of them are justified if you have 5 acres. A lot of you do. You know, some of you live out way out, you know, in the rural areas that I yearn to be. Must have a significant issue of law. We talked about that in your legal defense committee today. We had our first meeting of the year from 10 to 11:30, and we talked about what that really means, or it can be likely to be a persuasive example which other courts or boards are likely to follow. We can have initiatives involving bylaws, regulations, matters that have potential. We can do other things for you. Activities must maximize leverage, highlight, well, I've already talked about this, high likelihood of success, high value to amateur radio, and where an unfavorable result would impact all of you if you live in that region of the country. And this is important. We have to have financial participation by the amateurs. We're not a charity of sorts. We assist on things that can affect you, not just the ham who has an issue. It has to be supported by that ham or by the local community, and we've seen that. People step up and say, well, if the ARRL is going to cough up a few bucks, maybe we will too. And they have to be informed. What does this mean? Why are we doing it? Does it go to work? And for bylaws and things, zoning regulations must be a well-developed effort. We're not going to step in and be, you know, your public assistance law firm. Yeah, other, not to exceed 10,000, we can do other things, decisions on a case-by-case basis. If you have something, a legal problem as a ham radio operator that is not covered by some of the things I just talked about, we can decide on a case-by-case basis whether what we do with that matter will affect all of you. And if it doesn't, we're not likely to look at it too kindly. We'll think about it, and it has to be by a decision of 2/3 of the majority of the committee. The committee is made up of 2 directors, 1 or more vice director, an experienced attorney, not a member of the league. We have one of those from Western Pennsylvania, and league counsel, David Siddell, K3ZJ, who I met with today as well at this meeting. So I'm going to wrap this up so we have time for some questions. I think the greatest threat that we have as radio amateurs, I used to think it was antenna rights. This is an older slide. It's actually spectrum threats. I won't talk about those, but when I give a talk as director, some of you from the Atlantic may have heard this. The 3 things that keep me up at night now is spectrum protection, spectrum threats is what keeps me up, antenna rights, and RFI. If you have spectrum, you can worry about all the other things. If you have no spectrum, and we're headed with some threats coming down the road, then it doesn't matter whether you have antennas or there's any RFI because you don't have any spectrum. And if you have good spectrum, and we do, and you have no antenna rights, you can't use them very well. And then, of course, RFI. If you have the first 2, and I do a lot of RFI cases. I work with FCC Laura Smith on helping people helping hams formulate RFI complaints. Power wires are the big ones. Imported equipment, pronounced China, that isn't compliant with Part 15. That happens all the time. Whether it's a $400 pool pump that radiates 20/9 noise 1,000 feet away all over the spectrum, or a power, electronic device of some sort. We're seeing a lot more of those. How many here, real quick, has had RFI issues, things that they have? Yeah, okay. Yeah, it's not just me, see? Yeah, that's becoming a real threat. But As you see here, PRB1's a paper tiger. I think I have litigated. I have a slight difference with Fred Hopengarden, who has successfully litigated some of these, and we do have some decent law, but it's not a statute. It's an interpretation of a regulation. And under a Supreme Court decision a few years ago, they said that private individuals cannot file suit under what's called the Armstrong Supreme Court United States decision, cannot file suit to enforce a federal regulation. It has to be the FCC. That is becoming a significant worry of ours, and we're trying to fix that. Some state laws are more effective. HOAs we're working on. We'll entertain questions about that. I'm giving a talk tomorrow at the ARRL Members Forum. It's from 11 to 12:30, but my talk is, who knows, I'm sort of at the end, and I'm going to present the status report to you on what we're doing with the HOA bill. How many people here live in a homeowners association, or it's more than I thought. Yeah, see, it's a problem. Some of you can't help it. There's little choice, or you got in a ham radio after you bought a place that has an HOA, and suddenly it's like, what? I get a lot of those calls as well. Not much we can do about those, by the way. There are some things, but with this bill, if it passes and we're making some progress, I'll report on tomorrow, because members want to know. If it goes through, you'll have a lot better time trying to operate. Because without antennas, we can't enjoy our spectrum. And my closing shot, our community is all of you. I'm real big on this. The ARRL is a member-driven democracy in which the members shape policy, and you do that through the power of the ballot. I want you all to remember that. It's really important, more than you could know. We'll take questions. Any question is game. We got one here in the front. You want to give him a microphone, this gentleman? Looks like we got some time, so we're going to answer everybody's question. If we run out of time, we'll stay here. You can come up and talk to us. Sir.
Most people will know that I probably didn't need this, but we'll go with it. I'm running into a situation that is completely different to some extent. Call signs. I do software documentation, and if you're doing ham radio software, we have call signs. You have to enter call signs. And I'll enter, just come up with a random call sign, and twice now I've had to withdraw documentation because I got a contact from somebody. You use my call sign, which I just randomly selected, in your documentation, and you can't do that. That's my call sign. I have the right to it.
Are you kidding me? That's okay. Well, we'll talk to you afterwards. Part of my practice is intellectual property, including copyright, patent, trademark, all that kind of stuff. And that I'll talk to you. That's a special problem. But don't leave, and I will give you my answer. Fair enough? Okay. Don't leave. Next, this gentleman here has been waiting. Okay, sir. Push to talk.
Hello.
Works.
Okay, now, had to let a lawyer do it. I live in a retirement community, which looks a lot like an HOA, but it's not, because I don't own anything. I'm trying to put up an antenna, and it doesn't look like I'm going to succeed. Does anything you talked about apply to this private property type situation?
I'll answer that.
Yes, go ahead.
No. And the reason is you've signed a contract. You're a tenant under a lease. Those are the terms of your life.
Yeah. Now.
You have a lease. Of course you have a lease.
Yet.
And they get to decide what's in the lease. You get to decide whether it's to sign it or not sign it.
Let me add.
Them's your choices.
Fred is right. Let me add some comments. Did you read your lease? It's probably 30 pages, but you need to find out or have a lawyer look at it for you that knows something about radio to tell you whether it specifically excludes something like a wire out the window. I'm willing to wager it probably does. No clotheslines, no pink flamingos in the front yard, and I get that. Now, the HOA bill, I would say, Fred, what's your opinion if we pass what we've been pushing? Will that affect a lease? A lease?
No.
No. Okay, so that's not going to help.
It's not. The reason is the definitions clause.
Yeah.
The definitions clause in the ARRL HOA bill does not talk about
leases
and tenants. What?
Right, right. Look at your lease. Okay, look at your lease. Next question.
Okay, mine is sort of like theirs. I live in it. We don't have an HOA, but when I called the city and I talked to them, they told me what I had to do was I could put up a 30-foot tower, or I could go 10 feet above my roof. Now, I can't put a tower in the front. My backyard is 22 feet lower than my front yard.
Right.
Is it aggregated off my front yard or my backyard for that light height?
Yeah,